Welcome everyone. Today we are starting a new series and it's all about the Java programming language. I haven't done these full tutorial series, so it will be fun to try out a full language series on the Java programming language, a language that personally specialize in. So yeah, we will get started. Um, in the next few videos, I will be teaching you all about the Java programming language and how it works. And by the end of this video, I would say you're pretty good at Java. Now, don't take this as professional advice because there will not be any quizzes or tests as this is not a course. It's meant to be a tutorial, and please don't use this as your interview material. Please consult a professional for that. So, without further ado, let's get started. So, why would you want to learn Java? Now, some people have said that Java is becoming a dead language now that we are in the 21st century. But I'm gonna say Java is by no means a dead language. Even though Python is catching up, but Java still remains number one because the truth is, guys, Java is never meant to be popular. It's not popular for, the beginners, so you aren't exposed to the language more. But I'll tell you, Google, Facebook, Amazon, they all use Java in their servers. They just don't tell you that. So one might believe that Java, isn't a popular language. But remember, it still is, and it will earn you a high salary. I believe it has still the most job projections based on programming languages of this year, which is 2020. So learning Java is very important, and yeah, so I want to teach you that. And remember, this tutorial series will only be on the language. I will not teach you how to set up the IDE because I feel like if I teach you to set up on a specific IDE, some other users may not know how. So there are plenty of tutorials on the internet, and I really don't care what IDE you can use. You can use Notepad. As long as you have a Java compiler, you can get started on this tutorial series. I personally will be using the Eclipse IDE because I have been using it for many years, and I will continue to use it because it is very easy to use. But you guys can use anything. I'll teach you all about the language and object-oriented programming. So yeah, let's just jump into it. So first of all, we are going to take a look at the most basic type of Java program, which is the Hello World program. So let's go. So right now we are in Eclipse IDE here, and this is a Hello World program. Now this lesson isn't going to be that complicated. We are just going to talk about some basic things, and one of the basic things is this Hello World program. I don't know what IDE you're using, but I would assume that you have a run button here. So I'm just gonna click run, and in the console, all it does is print Hello World. Nothing, nothing too serious, except this is different from other languages. As you can see, there are many things that require to print this Hello World. And no, it is not a one-liner. You can see it takes up to 5 or 6 lines if you don't count the spaces here. But I'm going to show you what all of this means in a second. So, let's start with the most basic, which is system.out.println. Now, this is not in because this is an L right here. So line, it extends to line. But since it's shortened, we do print line. Now, I'll go over what print line means in a second, but so this whole thing here is responsible for printing Hello World. Now, what this is, if you notice, this is actually a function. So don't worry about the public static because we'll cover that in a later tutorial. But you can see that we have a return type, which is void. It's not returning anything. And the function's name has to be called main for this to work. Let me just demonstrate here. If we have another function, for example, void hello, and then we do this, and then we make it print system.out.println and hi. If you see, if we never call this hi function, it will only run main. So let's run this. And you can see that it prints hello world, but not hi. So again, main is a special function, and I would suggest you take note of this format because this string args, this is also required for the main function to run. If we remove this, let's just remove this for a second. You'll see it will result in a compilation error. So let us run here, and then it will just see, you see error, main method not found. You must use string args. Why? Well, I'll tell you later in the tutorial, but it will all make sense, I promise. So we'll have to put this arguments back for the main function to run. Now, the main function has to be in lowercase, and it has to contain this. Alright, so that's the main function. Don't worry if you're confused. I'm just telling you right now how to run a simple program. And now we're going to move on to some syntax. So Java has the use of semicolons. Semicolons must be placed anywhere that you have a statement. So in theory, we can all wrap this into one line. So instead, let's say we do another print statement. We can do system.out.println. Let's do hello there. So hello there, and then we will not do any semicolon. As you can see, it's already throwing an error. You have to say insert the semicolon. Nothing too serious, but if you do not put the semicolon there, it will cause you a lot of pain to find out where that semicolon lies. So this will print hello world, hello there in a separate line, like so. This is why print line exists, because we can also remove this ln function to print not in a line, but in an extra thing. Actually, this wouldn't work because it will automatically print a line. But we'll talk about strings more later, but if you can see, this wouldn't print two things as a separate line. This will only print hello world and hello they're squished. So you can see they're squished because they're not print line. Anyways, more on that later. So Java, the Java Oracle guide states that all Java projects have to contain packages and this source folder. So this is my Java tutorial series. I have a bunch of other projects here, but mostly we are going to work on this tutorial series. Now, depending on which IDE, again, I may not know which IDE you're using. Just follow its instructions to create a project. You'll see that this is the Java runtime environment. This do not touch because this contains all the things you need for Java to work. Now in here we have the source folder. Now make sure to name it src or else Java wouldn't know it's the source folder. In here we have this package called the tutorial, and in here we have this thing called main.java. Now I'll explain what the package is. So in this first line here, we have package tutorial. All we're doing is we're telling that this file belongs to this package. So if we rename this to package core, all we have to do is type package core. But of course, right now, you can see core is undefined because we don't have a package core. So let's go back to package tutorial. And this main.java is your class. Now, don't worry about what class is. It is the thing that says public class main. Now, if you do not know what class is, just put it there for now. We'll talk about classes later. But your class name has to match with your file name. So if you type class hi, let's do class hi, you can see it'll throw an error because it'll say hi must be defined in its own file. You have to rename this to hi.java. So we have to do class main. Other than that, that's pretty simple. That's all the packages and the project and the classes are. So right now we can also do comments here. So we can define some comments. Comments are pretty useful, especially when communicating with other developers. So comments, just two forward slashes, and then whatever you want to type. So let's label this print hello world and hello there. So the compiler will ignore the statement and it will do whatever you want it to do. But if we remove this, it will throw a bunch of errors because like it doesn't know what these symbols are. So let's put backslash. Now you can also make multi-line comments by doing a forward slash and a star. So that way it comments out everything. So we can just do that and it will say print hello world and print hello there. So that's a multi-line comment. And this is a single line comment. So that is basically it for today's tutorial. Very short and simple. You learn how the main function works, how to print some statements, and how the package and the file system of Java works. Next tutorial, we will get deeper and more serious into Java by talking about variables and data types. So again, next tutorial, we will be talking about variables and data types. And yeah, so that is today's tutorial. Thank you for watching. I'll catch you in the next one. What is going on, guys? Welcome back to the Java tutorial series. Today we will be talking about variables and data types. As in the last video, I'm telling you it's gonna get serious real fast. So enough with the intro, let's get straight on to variables and data types. So right now I am in my Eclipse. This is from last time. We have our hello world here, and in fact our hello world things are printed here just for reference. You learned last time how to do comments and other stuff. If you do not know how to do this, please check out my last tutorial. It will be building off of that. So this time we are going to do variables. Now variables are probably the single-handedly most important thing ever in Java. So let us delete this and we will actually create a variable. So to create a variable, all you have to do is type its variable data type and the name. Now don't worry what data type is. I will show you what data types are in a second. But one data type could be a string. If you know, a string is anything, a string is anything from, text. So we can do string, my string equals hello world, and like that. Now it will get defined here. Now, remember, string is a data type. It describes what type of things are put in here. And my string, well, that's just their name. So now here's the deal with the naming convention. You can't put numbers in front, because if you look at here, it says you can't put 4. Just can't. And other than that, I guess you're not limited. You can't really put like, special characters or anything. But I wouldn't associate with that anyways. But you can put numbers here. You can put numbers here. You can put numbers here. But just not in the front. So that's all the naming rules for the string. I usually name it camel case. Camel case is just where the first word is lowercase and second word. Some people do Pascal case, which is both words, so my string. Some people also prefer my string, but that's hard to read and it looks like some other word if you can't tell. For example, if you say my string buffer reader. Now, don't worry about buffer reader, but just imagine you're in a complicated project. Like, that's hard to read, so you wanna do the capital, and there we go. Now you can see the clear words generated by this string. So that is that, but we are going to do my string, and my string will be hello world. Now, the variable could be used to other extents. For example, let's do system.out.println my string. So you don't have to write hello world anymore. You can just write my string. And if we run this, it will print hello world. So hello world here. There are other data types which we are going to talk about now. My string can be integer, but it wouldn't work if you have hello world here. So let's do int my int. Now hello world wouldn't work because obviously it's not an integer. So we wanna do an integer. Let's do 54. That's a perfectly fine integer. Now you might have noticed this integer is orange, but this string here is blue. What's going on with that? Now, here's the deal. There are primitive data types and non-primitive data types. Now, I'll show you what they mean. So, primitive data types, I'll just list them out in a comment. So, these are primitive. Oh God, am I spelling it wrong? Okay, I'll just do prim data type. Prim data types, they are integer, they are boolean, or I can just use the shorthand double, float, char. What else is there? So we have char, float, long, short, byte. So long, short, and byte. There we go. These are all the primitive integers, and we will export them in today's lesson. The reason why we don't want to do the non-primitive data types, because they can be created with classes. So yes, you can create your own data types, but that is a later tutorial. Did I just say primitive integer? No, yeah. The previous thing, it's primitive data types, not primitive integers. So sorry if I said primitive integers. Primitive data types. There we go. So these are all the primitive data types in Java. These are defined by Java themselves. So you want to take note of them, do what you want to do with them. You know, that is up to you. But these are the primitive data types. In fact, one of them is int, and these will all have the yellow, the orange highlight. So anything other than the int, it's not going to be orange. So we are going to take a look at each one of these. So let us get some room here. So primitive data type, like integer, that pretty simple. Integer, we have x equals 5. Pretty simple. Boolean, also an orange one. Also pretty simple. So it represents two values, true or false. Double is your decimals. So decimal double, my double, you can do 6.3. So these are all integers. But here we have some limits. We have some limits with the integer. So integer limits. So you cannot store a number less than this or greater than this. Otherwise, Java will fail. There are numbers. Actually, there are data types for numbers greater than this. So that is the long. So long is a data type that stores long numbers. So we can do my long equals, and then we can do this without getting an error. Like so. Oh, maybe too long. Alright, let me check the long, okay, so yeah, we can't go too long despite its name, but it stores on this disk, so we can actually probably go from here. Yeah, there we go. But integer, you can't get anywhere near that. But one thing I will say, a float is one thing that I guarantee you can store probably up to like infinity, because this will work. But here's the deal with this. The reason why it's saying it's out of range, because a float is a fractional digit, so you can't really do a very big number. It still complies with this rule. But if you do a decimal point, it will all work out, because here's the deal with the decimal point. The decimal point actually defines the digits below that. So let's see what it's. Oh, can't do decimal points, because decimal points are for doubles. So decimal points are for doubles, and the float, you have to put F behind it. Sorry about that. So we can do that and this, but we have to put F, and as you can see, it can store way longer than long. So we put, I believe, an L. Yep. So My mistake. Did not realize. Forgot we had to put F, because if you don't, you know, bad things will happen. So you can't. You can pretty much go to infinity with float. So the float here, it goes from. Let me just bring out this range. So let me get this here. There we go. That's for the long. The integer is that Boolean can store only two values, and that would be the true and false. Long can store from this number to that number, and float, I will just tell you, float straight up is insane. It can go up to, well, it can actually go up to, you know, 10 to the 300 power. That's 10 with 300 zeros. So it can go up to 10 to the 308. But let's just go 10 to the 300, because up there you can have some pretty weird behavior with that. So 10 to the 300. So that's the equivalent 1000 all the way. And as you can see, it's fine because it is a float. Now, you can't do that with integer, because if you do that, yeah, it's going to be out of range. So, integer cannot, but float can. Now, double can also go very high, but I don't think double can go as high as float. Or maybe, okay, maybe double can store more, it can store up to 15 decimal places. So that is the double, float, long, and also we have short. So short is another data type, and the short data type is going to be a very short number. It can only store numbers from negative 30,000 to, yeah, positive 30,000. So that is the short data type. As you can see, you can't really store much, but it'll be useful for storing stuff like, you know, short numbers. So like that will work. Now, short data type, long data type, float, double, all of these are conformant to powers of 2. Why? Because, well, obviously everything is in binary to the computer, and it depends on how many bytes each data type can store. So 2 to the 32nd power, I believe, is this number here. I may be wrong, don't fact check me on that, but I think this is 2 to the 32th power, and this is 2 to the 64. So when you hear 64-bit integer limit, you'll know that this is a 64-bit number, and this is the maximum it can store. So that is the 64-bit integer limit. More primitive data types coming your way, but not going to do with numbers. So we have a char data type. So this char data type here can only store one character. So we can do char my char equals b. That's it. If we do ball, it will throw an error because that's multiple characters. So there are also a byte. A byte is even shorter from than short data type. It can only store can only store variables from negative 127 to, I believe, negative 128 to positive 127. So you can do byte, my byte equals, that will work. But if you do 844, it'll be out of range. So that is pretty much it for the data types. Again, there are many more data types, and in fact, the amount of data types there are might just be infinite, because you have non-primitive data types that you can create yourself. Yes, you can create a data type, but primitive data types, surely they aren't infinite. These are it. These are all the primitive data types. And I made some comments here, so you can see that all the primitive data types are here, highlighted in orange here, but string is not a primitive data type. Why? Well, it's actually made from a primitive data type. I'll let you guess, but I'm just gonna say it right now. A string is an array of characters. Let's be honest here. If we have a string called actually let's do this ball, right? So ball is a string, but if you notice, it's just many characters stacked up together. Now, we'll go over arrays in another video, but it will make sense what I'm talking about with the array and the character. So, that is it for today's lesson. Next lesson, we are going to talk about control flow. If you don't know what control flow is, it's your loops, your if statements, your switch statements, all of that. Very simple. But I'll catch you in the next one. Until then, I'll see you later. Welcome back to another Java tutorial. This is lesson 3, and we are going to talk about control flow. So this will cover the conditional statements and the loops. Usually the loops will be their own episode, but since the if statements are really short, I decided to combine the two together. So this will be sort of a long video, but hopefully we can get through everything in a reasonable amount of time. I don't want to keep you for too long, but we will get started here. So we're going to head on over to Eclipse here. This is from last time where we explored all the primitive types. So we are just gonna erase this. If you want to look at these comments, please watch my last video. It would be lesson 2. So now we are back in this main function. We're gonna talk about functions in the next episode, but so far we are still going to use this main function to run all our code. So we are going to talk about if statements first, and if statements are pretty simple. So you wanna type something like if, and then parentheses, if 5 equals 5, which it does, then system.out.println, it does. So we are going to check here. It does. So let us run this here. As you can see, it should say it does, and it does. But obviously it is not suggested. That's why Eclipse highlighted. But this is for the sake of demonstration. In real life Java, you wouldn't just compare two identical things. But notice how this is double equals. Now this is comparison, because if you remove this, it will become assignment. What you're saying, you're assigning 5 to 5, which doesn't make sense because 5 is already equal to 5. So we want to type both equals, and that will output true. So it's also the equivalent of true. If true, then system.out, obviously it's true because, you know, if it, and it prints out that because it is true. So if this statement is true, then it will print out whatever is inside. Let's do something else. So let's assign this integer to x equals 74 and y equals 84. So 10 apart. We are going to compare x equals y. Obviously they don't equal each other, so it would not print. But let's make it a condition. So else if, so this is like else, you know, else if x plus 10 equals y, then you can print out x plus 10 equals y. So we can do yes it does. So we're looking for the yes it does and not it does, because it does not equal each other, but the plus 10 does. 74 plus 10 equals 84. So let's run this, and you see Yes, it does, but not it does. So that is basically, you can do numbers. You can also compare strings, which is pretty easy. All you have to do is match each other. So for example, if I have string, my string equals hello, and we can just duplicate this, my string 1, so you can compare my string 1 and my string, it should equal true. So that's string comparison, but we are going to stick with numbers. So now you know that there's an else if function here that exists in Java. You can do else if, and you can also do some other operators. So we can explore with this. So we can say x is less than 74. So to do that, let me just delete this first. So to do that, we are going to use the less than symbol, which is this. X is less than equal to y. So we can do x like that. So it should print this. And yeah, it will just print x is less than y. We can also do x is not equal to y. So using that, we can do exclamation mark, and all that does is saying x does not equal y. So does not equal, which will also be true since they're not equal. Right? See, like that. X does not equal y. And finally, you can have the else statement, which is if nothing works, then you can do system.out like x is not defined or something like that. But that is the else statement, which is pretty simple. There are also some logical operators we can do. So we can do or statements. So or statements are defined by 2 vertical lines, and statements 2 ampersands, and not, you saw not, which is the exclamation mark, which is not x or not y. So let's see, we can define a boolean, which is boolean high equals false, right? And we can do not high, and it should print x does not equal y, because not high, which is the opposite of false, is true, and we saw if true, it will print out whatever is in here. And yeah, it prints out x does not equal y. So that is basically if statements in a nutshell. We're all gonna talk about loops. So let us do this. So loops are pretty simple. First loop is while loop. So we can do we can set a number. So like I equals 1. And then we can say while I is less than 10. Do system.out print line I, which is printing the number. Whoops, I don't know why that parentheses is out there. Alright. Print I and then I plus plus. Now, here's the deal with I plus plus. You have to put it there, or else the while loop will never increment. It will just always print 1, 1, 1. Actually, it wouldn't print anything because it's saying while, yeah, it will print 1 forever because you're not adding anything. It will cause an infinite loop. So I plus plus is equal to I equals I plus 1. It will also equal to I plus equals 1. But I plus plus obviously is shorter than all of them. So this will increment, this will print from 1 to 9. Why 9? Because I is strictly less than 10, it will not print it. So let's print this here. As you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Not 10 because we add a less than or equal to, then it will print out 10. So let's run this, and look, 10 is printed. So that is while loops. Very, very simple. Now there's a inversion of a while loop called the do while loop. So a do while loop is actually the opposite. It will run whatever in here is first, and then it will check the condition. So 1 will be printed no matter what the first time it goes around, and then next it will check the condition. So let's do a do while loop. So all we do, we move the while loop down here, and I believe we add a semicolon. Yep. So it'll print it'll print I no matter what. It'll add I no matter what, and then it will check if I is less than or equal to 10. So let's run this. You can see everything is normal because we do have the 1 and 2. So, but we can't do if I is less than or equal to 1. You can, oh, actually, if I is less than 1. Usually in the while loop, it will just stop. It will not print anything because it will check. Oh, there we go. I is 0. So the while loop is saying, okay, I is greater than 1. So let's change it to a 2 actually. I is greater than 1, we should stop running this. But in a do while loop, it should print out 2. Yes. Now here, that's what I was saying here, because the do while loop does not, it ignores the first time around. So it will print whatever it is in here, and then it'll check. So obviously 2 is greater than 1, but in a traditional while loop, it will just stop printing anything. Let me just show you here. We have while I is less than 1, which it is, and it should not print anything. So the result should be empty. And look at that. The result is empty because the do is gone and I is less than 1. So that is while loops and do loops. Now we're going to talk about for loops. For loops is another great loop, but this time it combines pretty much everything together. So we don't need to add a variable declaration outside. You can do that within the for loop. So all we have to do is for integer I equals some number. Let's do 1 again. And then what do you want I to go to? So we can do, oh, my mistake. I is equal to 1. I is less than equal to 10, and I plus plus. There we go. There we go. Eclipse was just having some issues there, but this is the equivalent as the while loop we did earlier. But instead of doing the I plus plus in the loop, it gives you a little feature here to do the I plus plus. So we can just do system.out.println. I like for loops because it literally combines everything. So it should print exactly the same as the other while loop, which it counts to 10. So let's do that. Oh, I is less than or equal to. Sorry about that. That is supposed to be less than or equal to. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is for loops. For loops, you can also mess around. You can count backwards. All you have to do is type 10, and then I is less than or equal to 1. So just switch them. And then for this section, you want to type I minus minus. So that will make it count down from 10 to 1. Yeah, I messed up the operator signs again. So again, check your operator signs. I did less than or equal to, but it's supposed to be greater than or equal to. So my bad. Now it should count from 10 to 1. So that is for loops. And yeah, nothing much to say about that. We are going to move on to switch statements. So if you do not know, a switch statement is actually another type of if statement. So you define switch statements like so. Switch statements aren't really that hard, and yeah, so switch statements can come in a variety of ways. Most common switch statements are switch and case. So I will tell you how to do switch case. So you want to do this switch here. So you want to have basically a conditional that is met with the switch statement. So a switch statement, you want to do like switch. Okay, so let's do integer here. So let's type integer x. Let's do it 1 again. All right, and then we will be switching x by an order of 2. So all we have to do is type switch x plus 2. So it will just keep. It's kind of like a for loop and another loop mushed together. Let me see. Okay, and then you type it like so. Yep, and then so switch statement is also like a block. You have some cases here. Not sure how to explain the cases, but it's basically you basically want to have a case, and that was the conditional here. So switch, you have case 1, and then you want to do system.out.println case 1. And again, this case could be anything, but right now we're just making it print stuff. Case 2, system.out.println case 2, and case 3, system.out.println case 3. And we also have a default, aka if none of the conditions in the cases meet, we can just do system.out.println default. There we go. And if we run this, as you can see, it prints out case 3. Why? Well, because x is 1, and 1 plus 2 is 3. It also print default because it'll print default no matter what, because that's the default case. But if we change this to 0, it should print out case 2, because 0 plus 2 equals 2. It will switch it between the case. And here's the deal with this. It will print case 2 starting from case 2. This is very important, because you can see it also printed case 3 and default. Why is that? Well, that's because it starts from case 2. It'll just keep on printing cases that are greater than it. So you can see if we move default up here, it's usually a good idea to move default at the very beginning. So default, it will not print default, but it will still print case 2 and case 3, because it's kind of like a waterfall action. So case 2 and case 3, but no default, because default is moved on top. And that's usually the recommended way. Put default on the top, or else it will print default no matter what. So print default at the top, and then usually if you are having this ascending order, you should actually move 3 to the top and 1 to the bottom. That way it will only print 2. But so far this setup is pretty good, and that's basically switch statements. So you can adjust this. You can do 2 plus 2, which is 4, but we don't have a case 4, so just print default. Yeah, that's like that. And now the reason why it printed out all 3 cases, remember, it's not because it thinks it's all 3 cases. It started with default, which is what it's supposed to print. But then case 1, case 2, and case 3 are underneath default, so it automatically prints all of them. So how to fix this? You can type a break. It'll break out of the switch statement. That way it'll only print default and without, and it will print. So it's recommended to break out of your switch statements each time you have a case, so that it doesn't run every single case underneath it. As you just saw, we can add a break, and then it will just actually run this switch statement. That's pretty much switch statements. I'm trying to think what else we can cover here. We can't cover loops. I mean, not loops. Arrays yet. Arrays are another episode, and functions are also another episode. So I guess that is it for today's lesson. So we talked about if statements, loops, and the switch statement. Switch statement is kind of obscure again, but I did show you the different types of switch statements and how each one of them worked, and now you'll know how to do all this, and I'll see you in the next one. Thank you for watching. Welcome back everyone to lesson 4 of the Java tutorial series. Today we are going to be talking about functions and how to document your code, which is using Oracle's built-in method is JavaDoc. So quick and simple episode. We're only going to introduce you the basics of functions. No, no complicated stuff, but I will tell you, this is not the last of the functions. They will come back, and they will come back in a different form, and I will just warn you, they will come back in a more advanced form. So you better catch on with what I'm saying today. But yeah, let's just get started. Enough introducing, and yeah, let's head on over to Eclipse. So we'll just open up Eclipse, and yeah, look, this is our basic setup here from lesson 1. We talked about the main function, which obviously it's a function here, but we are going to define our own function. So let's start by defining our own function. So we are going to define a function. It's going to have a return type first, and then the name, and then parameters. So you see what I mean. So a return type is a data type. We talked about data types in our second episode. So one data type we have is the integer data type. And then let's just do a simple add function. So we do an add, and then we want to take 2 parameters, because we want to add 2 numbers. We want to do int a or x, and int y. So int y, just generic variables, and then we want to return x plus y. So pretty simple, pretty short. Nothing bad with that. And now we are going to, again, this is declaring the function. Now we're gonna call our function here. So we're gonna do system.out.println add 7 and 4, so it should equal 11. But look at that, we define our first function. So let's just run it, and let's run it, and there's an error. Why? So the error is expected, but here's the deal with this. Okay, so the error is complicated, but what it's saying is that you can't really call this function without assigning an object to it. Okay, well, what's an object? Well, you'll see in lesson 6, but basically, an object, it has to do with object-oriented programming. We'll talk about that later, but for now, if you want this to work, you'll have to add static in front. This will basically, eliminate the error, and you can also call the static method to the static reference. So why static? Well, you'll find out in a later episode. I don't really want to go too deep in this episode, but later episode you'll find out why we had to put static in front and what happens if you don't put static in front. But for now, just leave that there, and now it should run perfectly fine. So let's just run, and you can see it prints out 11. So nothing too serious there. We can also do different return types. We can do Boolean return types again. Okay, but there's also a special return type, which is the void return type. Now, void is not a data type. It's a function data type, which is exclusive to functions only. So let's do a void data type. Remember, if we want to call the function, we have to type static, and we got to do static void. And let's just do a print statement, because I don't know about you, I don't really like to write a print statement that often. That giant clunky system.out.println, yeah, that's not my style. So I'm just going to define a function that just simply prints a string. Now we don't have to write this long mess. All we have to do is we can just write print and print hello world. So instead of the first day hello world, we can just write our new function here, and now we run it, and it should do exactly the same thing. So that's the usefulness of functions here. So knowing this knowledge, we can actually dissect the main method here You can see the main method is static, aka you can actually call it from anywhere else in the function. So we can actually do main like that, but main, and then you can see it returns void. Obviously it's a main function, it doesn't return anything. And you can see there's also some parameters, which is the string args. Now the string args is actually an array. So we'll talk about arrays in the next episode, but this is basically Java's way of saying this is where execution starts and this is where execution ends. So that's the main function here. And yes, it must be called main with the lowercase m and everything. So public, you might ask what is public. Public is have to do with the class, and we'll talk about public in episode 6. So hang on steady there. We aren't going too fast yet. We just want to establish some foundations here, but we will get to public. Everything on the screen will be explained in this tutorial series. So now that's functions. Yeah, it's pretty easy. But now we are actually going to talk about JavaDoc. So JavaDoc is a good way of documentation your code, because let's be honest, we don't want to read all your code. We just want to know what it does, and you know, if you work for a company, I bet that's what your coworkers want to do. They don't want to look at your code. They just want to use it, know how to use it, so they can implement it in some other things. So let's actually document our functions here. So to document your functions, we are type a forward slash, and then 2 asterisks, kind of like a comment, but not really. And you can see automatically Eclipse is good by adding some things we can do here. So this is for the int add function. So you can see it can have the JavaDoc automatically create something. You can see it creates the parameter x, parameter y, and the return statement, which is x plus y. So you can see on my left side here, Eclipse automatically creates this this formatting thing. So that's useful because you know you want people to know how this function works. So we can do that by saying takes two numbers x, y, and returns the sum of x and y. So on the left hand side, you can see takes two numbers x, y, returns the sum of x and y. Parameters x, y, returns x, y. Boom, simple. That's JavaDoc. Let's try to document this function to prevent your work from getting stolen. You can also assign yourself an author. So author, boom, like that. Parameters s, it returns nothing, so we can do return void. And we can also assign a version number. So we can do version, and we can do version 1.0. This is for source control and other things related to, you know, version numbers and stuff. This is for, you know, developing software that, you know, version releases and stuff. But you can see Eclipse also formats this. Again, you can add a short blurb using the API note. You know, the function is takes a string and prints it to console. So that's your short note. And yeah, that's pretty much API documentation. It's not really that hard. This is obviously advanced form of comments, because you can obviously comment your code and say the same thing. But you know, this is just, look, this is much easier to read. You know this is the return type. You know this is the API note. You know this is the author. Instead of trying to write a whole paragraph, you can just use the JavaDoc. And in fact, the Java developers at Oracle and Sun, they also have used JavaDoc, and you can see that let's actually look at how this print line function works. So you can see in our left hand side we have a JavaDoc. So look, it also takes in a parameter, and it also tells you a little bit about the the function, kind of like what we did here. So we can actually go to the actual declaration here. So this we are going to the internal functions here. If it will open, let's see if we can open the functions here. Let me see. Open declaration. I guess. Okay, let's try to go in our system library here. You can see we have a lot of things here, but let us go to java.util. Wait a minute. Java.utility. Where are the utilities? Java. Give me a second. I wonder why they're not here. All right, let's see if they're probably inside Java. It doesn't matter, but you get the point. Let's open like a random thing. Let's do Java.compiler. Actually, let's not. Let's do Java.base, Java, and let's do the math. Let's look at rounding. So this is the internal version. You can see it is copyrighted by Oracle, and you have, if you want to use this, you must agree to its license. But we're not gonna use this. But you can see already there is JavaDoc. So you can see this giant paragraph, and you can see author. These authors created this, and this is the version, and then you can see the things begin. There you can see, like, also most of this is just documentation. I would say there's about 400 lines of code here, and about probably 300 lines of code, not lines of code, but lines is dedicated to JavaDoc. Very important. You can see Eclipse also creates some of this, but you want people to know what your code means so that they can use it properly. So this is an internal version of the JavaDoc. It's also a real life version. They also use HTML headers and stuff, but that's JavaDoc. But we can just stick to our basic here, and yeah. So today you learn about functions. You learn how functions work, and you learn how JavaDocs work. So hopefully you can take these two tools together, and you can create good functions, and you can create good documentation so people will know how to use your functions correctly. Next episode, we are going to talk about data structures. That includes everything from lists to arrays to other things that are related to data structures. Again, next episode, it will get more and more advanced. We'll start OOP the 6th episode, and yeah, it'll just be going skyrocket from there. So yeah, better get your seatbelts on, because we will not be slowing down. Java is a very, very intricate language, and this will probably be the last of the basics. We'll start accelerating faster and faster after this. But not to scare you off, but that's just the the reality of this. If I want to cover this material in a reasonable amount of time, I'll have to speed up here. So we'll see you in the next time, and yeah, stay safe, and yeah, we'll see you in the next one. Peace out. Welcome back to lesson 5 of the Java tutorial series, and today we're going to be talking about hash maps and array lists. So hash maps and array lists are two different types of Java data structures which can help simplify much workflow, especially if you're working with data science and other data structures such as algorithms and many other applications. So let's take a look at how we can learn how to use these array lists and hash maps. So let's go head on over to Eclipse here. So let me just close out. All right. So right here we are in Eclipse, and just as a review, we have this primitive array here, which isn't any of this import here. We'll get to this later, but this is your primitive array, and the reason why I want to show you this is because I want to show you the differences between an array list and an array. Now they're very different, as an array list has the keyword list here. The array list is actually a dynamic list, which is very different from a array. So here we have an array with all the digits. Technically we are missing 0, so let's add that. So we can create an array like this with the constructor with 2 brackets, and then you name your array like so, and then you define your array. You can also do another array by doing this. For example, let's do int digits, and then let's do digits a, new int, and then you can put 10. That will be the size of the array. So that will also work. But primitive arrays are not for the better, and that is why we are going to use array list from now on, as it is proven to be a much better alternative to a primitive array. But just so that you know, Java does support primitive arrays, and this is how you do it. So now you see I have this commented here, is I am going to teach you a new method. It's called the for each loop. So we learned about for loops before, but the for each loop really helps simplify how things work. We'll try it on this array here, and then we're gonna try it on the array list later, just to see how the for each loop is way better than the normal for loop. So let's see here. Do for loop, and then we can do our index, and then a colon, and then you put the array on the second parameter, so like so. And then we do system dot out dot print line, and then we want to print this is the exact same thing, and you guessed it, it will print everything out of digits. So let's run this and give it a second. And would you look at that, all the digits of the array. So that is the for each loop. Very, very useful. Again, this is the syntax, and it does exactly what you expected it to do. And yeah, so that is the array. Now here's the flaw with the array, which is that it cannot be manipulated. So you can't add anything to the array. You can't do so that's the problem with the array, is because most data manipulation requires adding or removing stuff. But nope, you can't. This is a fixed size. Once you have 10 10 values, you must replace it with either a null value or just zeros, which is obviously inefficient. So we are going to use the array list. So the array list, as you can see up here, is imported with java.utility or util.arraylist. So that is how you import it, and this is the line you are going to import. Just write that on the top. Make sure you spell it correctly, because if you don't, they will give you an error, because obviously that library does not exist. And we will import the hash map. We'll talk about later. Anyways, so let's do the array list first. So let's clear this out, because we don't need those primitive arrays. We are civilized. We use array list. Alright, so here's how we construct the array list. Now this is getting into classes, which is gonna be episode 7, I believe. So we're gonna have one more episode on data structures before the classes. So but I'll introduce you to the classes. So we want to create an array list by typing array list, and then this little bracket symbol like that, and then we want to populate the array list with whatever primitive or non-primitive data type we want. So again, the primitive data types are integer, character, what else, double, those are the primitive data types. But we can also populate with stuff like string, so that will work too. So let's just do string, because string isn't a primitive data type, but it still works. And then we will name our array list. So in this case, we can just name our array list cars, because why not? So we will just name it cars, and then we're going to construct it by using the new keyword, which we'll talk about in episode 7 when we do classes and objects. So new keyword, we do new array list, copy the beginning string, and then that like that. That is how you construct an array list. Now, currently the array list has nothing inside it, and of course, because we just created it. So let's add some things in here. Now, this is what I like about the array list. It's because it's just easy access API. Look at this. I'm just gonna copy this prefab here, but if we take a look, this is really self-explanatory. You have the array list dot add, and you want to add whatever you want in there. So that's pretty much it. So now we do system.out.println, and we want to print the array list out. So we just do cars like that, and then we press run, and we do like that. Very simple. No extra necessary stuff required. And the good part is you can add stuff to the array. Not only you can add stuff, you can also subtract stuff. So take a look. Let's, for example, this car assembly line does not want to put how do you say it? Manufacture a Ford. So we want to remove Ford from the array list. So we want to do it's just that simple. I want to just remove Ford, just like that. And then, as you can see on the bottom, Ford has disappeared from the array list, and now it's just Volvo, BMW, and Mazda. So that's pretty much how it works. You can also remove it from the index. So let's remove 0, which will remove Volvo, or we can remove 1, which will remove the BMW. So let's do that. Once we press run, BMW should be gone. So yep, if you look at that, no BMW here. So that is remove and adding. Very, very simple. But now we can actually take a look at another all-in-one package, which is the clear function. So we want to do cars.clear. All this does is it clears everything, wipes everything from the array list. So let's run it. And when you look at that, at the beginning we have all the cars, and at the end all the cars are gone. So as you can see, right off the bat, the array list is way more versatile than the primitive array, which is why I personally will use it over array in any circumstance unless not permitted, which there are some exceptions. We always have exceptions, but so that is the array list. Now we can also get a value, because we don't want to always add and subtract stuff. We just want to know what's in a certain spot. So we can, instead of doing that, let's delete this, and we want to get the value at 1. So again, it should be BMW. It will just return BMW because that's the string that we want to get. So if you look at that, there we go, BMW. So that is what we're going to do. Now we can change stuff by using the set method. So we want to just change this to set, and we want to set 1, which is BMW. We're going to replace it with Honda. So a new car, actually string, my bad, Honda. And actually we should probably put this up here and then print cars. That way we can have like that. Just run that, and boom, we have Volvo, Honda, Ford, and Mazda. BMW has been replaced. So very, very, very easy stuff. And back to the for each method, just want to have a side-by-side comparison of the for each method. We have the for each method. Let's get the for each method here. So we have for int I in cars, and let's print I. So we're going to print all the cars one by one like that. So this is the equivalent, hang on, give me a second, string. Yes, sorry, string. There we go. For string I in cars, just to give you a comparison on how how good the for each loop is. This is the exact, actually give me a second. We're not gonna print I, we're gonna print cars dot get I. Yes, because we want to get it from cars, not But so just to show you the power, or we can do I. Let's just do I, because I want to really show you how much you can compress this into one line of code. So this, for example, is your regular for loop, which I am going to copy over. And these do exactly the same thing. You can see we have from I equals 0, I less than cars.size, which is another array list function. We loop through everything, and then we have to do this cars.get. With this, everything's gone. Why would you do this instead of this? You see, that's the power of for each loop, and that is the reason why I would go with this rather than this. Obviously, there are exceptions with this. There might be sometimes you have to use this, but I don't see a reason why otherwise. But that is pretty much array list for you. So we have the for each loop. That should be a very good skill to acquire. You learn how to set values, get values, remove values, add values, and all of that good stuff. And now let's move on to hash map. So hash map is a different type of data structure that is completely different from array list, but similar in their own ways. So we want to do hash map, and this time we can define pairs of values. It's pretty much array list with pairs. So it consists of a key and a value. So the key is used to access the value, kind of like a phone book. And in fact, that's exactly what we're going to do. We're going to create a phone book. So we're going to define this. Your phone number should be an integer value, and your name should be a string. So like that. Phone book equals new hash map. And then we type the same thing. Integer, string. Like so. Construct the new hash map phone book. And then we can actually add stuff to the hash map. So that is your phone book hash map. So to do that, also very simple. We just do phone book dot put, and then we want to do 1 2 3 4. That would be the phone book, the phone number of John. And we can put another phone book. We can do a, let's see here, we can do 4 5 6 7. That would be the phone number of Jane. You can see where this is going. Let's just add a few more. We can do like so, and then we can change this to Jack. So we have 3 people which are in the phone book currently, and we can just do 8900. There you go. It doesn't have to be a certain number. You can, any integer will work, but I'll just do 8900, and this is a phone book, so we can use that. Now, when we try to get, we can get either their phone number or their name. So here's how we do it. So let's print out their phone number. So again, we're printing out their phone number. So we just do phone book dot get. All right, let's see. I wonder why Jack is blacked out. I'm not sure. Probably some issue with Eclipse, but there shouldn't be no error. So we do phonebook.get, and then we want to do Jane's phone number, which should output 4567. It says unlikely argument type, but because you usually wouldn't get the key from the value, you wouldn't really do that, but it should work. Okay. Never mind, it does not work. Get only works with keys. So we have to change that so that we have to get the name of the person from 4567. So it only works with keys. Ignore what I said. Please don't Pay on me on that. But we get the key. So now it should return J. And yep, J. So, yep, it only works with the key. So, remember that. Remember that. And, you can also add an item. You can also remove an item. Or you can also clear an item using the clear. So, here we can also use our trusty dandy for each loop here. Where's our for each loop? Alright. So we can print everything in here. So it should print all of this in the for each loop, but with a special twist. So we have integer I because that's the, that's your phone book, the phone numbers, and we can do this by doing for integer I, get the colon, then we do phone book dot key set. This way, it will allow us to print every single phone book address and phone book name. So all we have to do is we just do I, like that, and we run it, and as you can see, it prints out all the phone numbers for you. And we can do string I. This, instead of getting all the phone numbers, hang on. Sorry, we still use integer I, but if you want to get the names, I believe you do phonebook.get I. Yeah, that's how you do it. Totally. See, I'm not wrong. Yeah, that's how you do phonebook.get I to get the key, value. Without this, you get the key. So that is pretty much the hash map. So as you can see, a hash map is kind of like a map. You have your location marker, all of that, but it's actually just an array. I mean, a dictionary in Python. So that's your hash map. Now, there's one more thing I want to talk about for the array list, which is sorting the array list. Because instead of sorting it yourself, why not make the computer do it? So right now we're gonna sort this car's array list in alphabetical order. So we can check with that by, it's actually a pretty good competition problem, but we can check by using primitive array, because we wouldn't need to alter this array, but we will use this primitive array, or we can just do the primitive character array, and we do alphabet, and then we set it to a we set it to 26. So we have all the alphabet, and then we match each one of the first letters of the car names, and then we want to see which precedes the other, but that's complicated. We have a library to do just that. So again, we want to go on the top and want to import java.utility.collections. Maybe capital C. There we go. Yep, just like that. We want to do collections, and then we want to sort our cart. It's very, very simple. We just do collections.sort, and it just works like that. It just works like magic. Not really magic, but if we open this, it's compiled somewhere within the library. I don't want to look at it today, but definitely there's some code going behind there, but it will just do this for us so that we can maximize other stuff. And then we just have this, nice, lovely for each loop, and now it will print everything in alphabetical order. I don't know, but the order to me is Volvo, BMW, Ford, Mazda, and then when we sort it, Ford's at the top, proceed to H, Mazda, and Volvo. Now, here's the deal. You see that BMW is gone. Why? Because we did the cars.set Honda. So don't forget about that. You got to keep track of your code. If you forget, just type change BMW to Honda. Add comments, because if you don't miss that, you might forget that you changed the first order. So that is how you do alphabetical stuff. And just to prove that it also works on numbers, this collections.sort thing, pretty useful. So we can also do integer, and then we want to do random numbers. Let's do a integer array list. I'll do new array list, integer, and then we gotta construct it. Again, we will talk about constructors in object-oriented programming, which is pretty much having it at level 7, but I mean not level 7, lesson 7, but we will get to it at the end of lesson 6 by talking enumerations. But that's next time. Whoops, let me just get some data here. Let's just get some data. And that should do enough. Let me just quickly fix this. My numbers. Replace it with num. There we go. And now, when we do the collections.sort, so we do collection.sort, and we want to sort the number, and then we want to just borrow this for loop. But instead, we want to change this to integer. We want to do it to num. This should now print, 8, 12, 15, 20, so on. And when we run it, of course, it prints that first, but 8, 12, 15, 20, 30, 34. Again, I see that as least to greatest and alphabetical order. So, collection sort, very useful thing. Of course, you can write your own sorting algorithm. Again, especially with the numbers, it's easier than the alphabet, but what you want to do is you want to sort it with, in fact, I can pull up some of the sorting algorithms here in my algorithms library that I just have on standby because I was using it for another project. But we have many sorting algorithms. For example, if we take a look at this is a bubble sort. If you want to see the behind the scenes, this is pretty much how you do it. Bubble sort is this whole thing. You want to take the array and then it's sorted and then return the results. Insertion sort, same thing, just different time complexity. Again, insertion sort is faster. I believe insertion sort is just a little bit faster than bubble sort. Merge sort, again, lots of complicated stuff that I wrote. But that's the algorithms library. If you want to download this library, you can go to the link in the description to download this library. Currently, it's a work in progress, so I don't know why you want to download it. But if I were you, I would just stick to collections.sort, and that would get the job done. So yeah, so today you learn about hash maps, array lists, and collections. Not all of it, but just the sort function. So that is pretty much it for today's video. A little bit long. Again, it's only gonna get longer from here because we're getting into some serious stuff. So if you enjoyed this video, please leave a like, subscribe. By subscribing, you can get the latest notification on future videos I release if you enjoyed this content, and I'll see you in the next time. Welcome back to lesson 6 of the Java tutorial series, and today we are going to talk about stacks and enumerations. So these two are semi-related, but not really. But I wanted to get onto enumerations because next lesson we're going to talk about classes and objects. So classes and objects, again, are pretty much the core of Java. So we want to build up to that so that we can have a solid understanding of classes and objects. And now what you want to ask is, why do we want to talk about stacks? Now stacks are, and queues and decks, they're like all in the same category, but the reason why I want to talk about stacks is because how counterintuitive it is. It's not hard, it's just sometimes if you forget how they work, you can break everything in your code. So enough talking in the intro, let's just get on to Eclipse. So we're in Eclipse now, we have a blank canvas. Last time we talked about hash maps and array lists, and those are pretty intuitive. You know, you can add stuff, but stacks have a different sort of property, which is that they're like a stack of plates. So that's what I suggest you to think about, which is the stacks are a stack of plates. If you want to add some plates, I have some plates in here. So we have plate 1, so we want to put that at the bottom, 2, 3, and 4. When we try to access plate 1, what do we have to do? We have to pull out 4 first, and then 3, and then 2, and then 1. So that is how a stack works. So let's define our stacks. But first of all, stacks aren't a primitive, function. They have to be imported. But luckily, Java's runtime has a collection of good imports. So we just do java.util.stacks. So just like that, the friendly developers at Oracle, actually let me change this to stack, have created a bunch of libraries for us in the utility section so that we can use them. So let us define a stack. So to do that, same thing as array lists and hash maps. We want to do stack, and then we want to talk about what we want to put in here. So let's just put a string. So a string stack. So stack, and let's do let's do some cars here. So let's do cars again, and then let's follow through with our constructor, and boom, Eclipse automatically highlights. I don't know what editor you're on, but this should work like so. And now we can add some elements in it. So to do that, we want to do cars.push. So let us push some cars in here. So let's push Volvo. Oh, Volvo. Okay. Let us push Honda. So Honda in here. And let us push Ford. So we have 3 cars. And you know what? Let's, for the heck of it, let's push, let's push BMW too. So we have 4 cars in our stack, and if we run this, we can see that it'll print pretty much everything in the stack. So let's do cars.toString. So unlike a array list, you want to add toString or else it wouldn't print. So let's run it. And as you can see, it prints the order we added them. Seems like an array list so far. But the keyword is so far, because you can't really remove stuff. In array list you do, dot remove and stuff. But then no, there's none of that in stacks. You do a special function called dot pop. So we do cars.pop. And yeah, it takes nothing. So you can't really pop a parameter. It just pops the default last value. So that's where it gets counterintuitive. Remember, it does not pop Volvo. Because if it does pop Volvo, then it will become a queue. So queue is pretty easy to understand. Like a line, Volvo comes in. When you pop it, Volvo goes out. But stacks is different. It pops the last person who comes in. Or in this case, BMW. So when we run it now, BMW will be gone, but Volvo will be still here. So take a look at that. Now if we pop it again, Ford will be gone. So let's just do it. When we run, Volvo and Honda's there, and Ford is gone. So just like that, that is how popping works. You can see, kind of not hard, because again, I recommend you to visualize, it as a stack of plates, because you can't really take down the bottom one without taking the top one first, because then everything will collapse. So that's stacks. Now we can actually peek at a certain element. So we want to do peek, and this will return the top value. So if you're thinking about stack here, you can only peek at the top value because the bottom values are hidden. So when I run it, BMW appears. Now if we do cars.pop, guess what will appear? That's right, Ford will appear. So when we run it, And boom, Ford will appear because we removed BMW from the stack. Boom, BMW's gone, and now Ford is here. So that is pretty much how they work. One last thing about stacks is that you can actually search for an element. So all we want to do is we do search, and then let's search for Honda. So Honda will be indexed at 1. So they're still indexed at the same spot, but if you see here, this is different indexing. Again, I'm cautioning you, this isn't a queue. And Honda, the reason why it prints 3 is because BMW is the first one. So if you're counting from the top to the bottom, you want to count the top plate, which is BMW, and then the Ford, and you finally arrive at Honda, which is position 3. So when you're using this search command, don't, be cautious about that, because if you don't, you might accidentally wind up in a different array and stuff. So just be cautious that. If we do BMW, as you can see, it will print out 1. But if you counterintuitively thought about it, you would think, oh well, isn't that just like a queue? But nope, it's a stack, which is the last in is the first out. So this is very important. Let me just add it up here. So last in, first out. So remember that. So whatever you added in last, it will be indexed at 1. So yeah, one more thing about search. Let's add some RAM card that doesn't exist, like this, a RAM string. So what would this print out? It will just print out -1. So if you're using that for some algorithms, that would be useful, because you can check if like something equals -1, if blah 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 equals -1, then do something if it doesn't exist. So that's how it works. And let's remove this. Now we're going to talk about enumerations. So enumerations are very, very special, because they are user-defined pretty much classes, except without classes, you can't really change them. So let's see how we can define them. So enumeration, we just type enum, and we want to define something that will remain true forever. So we can't really define, we can't define like usernames or account balance, because that would change. But one thing wouldn't change, for example, weekdays. It'll always be Monday, Tuesday. Oh, right. Also, the convention is that you want to name it all caps, just so that you can distinguish it between a constant and a variable. So variable can change, constants can't change. If you remember in science class, constants remain the same. So these are constants, and these are variables. So we'll talk about constants later. There, in the probably next or probably following episode. But right now we're talking about enums here, and this is what's going on. So we have this, and to define an enum, we want to type like so. We want to do weekdays, Friday equals weekdays dot. So yeah, as you can see, kind of looks like the stack constructor. We're constructing our own data type here, but not really. It's just an enumerator. So when we run this, let us print out Friday. It's gonna have you guess what it prints out, but obviously you will probably know it prints out Friday. So FRI. So because that's the enum. Same thing with weekends. We can add more enumerators. So weekends. That would just be Saturday and Sunday. We can also do this for country codes. So country codes. So we can do that. We can do United States, China, United Kingdom, France, Russia, so on. But all of this will work. And you can see country codes, weekends, and weekdays all have one property. They don't change. Unless something happens down here, weekends and weekdays don't really change forever. So you can use your code reuse the enums without having to worry about it being a constant. So let's remove this, and I'll show you how you can loop through it. So remember our friend here, our for each loop. So to loop through every single every single enum, we want to do weekdays. Actually, let's do weekends first. So you want to do weekends, and you want to define arbitrary variable. So let's just do underscore, or we can do I, and then our Google colon here, and then we want to do weekend dot value. So remember, actually values. So remember this, because this is important. It's getting all the values, and we'll just copy this. Once it prints I, it should print Saturday and Sunday. Oh yeah, Friday, Saturday, Sunday, because I forgot to comment this out, just to make sure no confusion. Saturday and Sundays. Yep. Just like that. Now, just prove that it actually works for other things too. We can change it to weekdays. Naturally, we have to change this to weekdays too. But now, this will print every single thing in here. Again, the power of for each loop. The more you learn. So, obviously, the comment Friday, but starting from here, ignoring this line, you have Monday, Tuesday, Wednesday, Thursday, and Friday. So that is the power for each loop. We're going to be using it pretty much for the rest of the series when dealing with stuff like this. You can do the other way around, but I don't really suggest it. But that is pretty much it for enums. Very good little introduction to classes. Again, not fully classes because you can't really modify them, and you can't really create objects with them. So this is constant. So that is pretty much it for today's lesson. We talked about stacks. Hopefully you'll get a better understanding on how stacks work and how enums work, which again, foreshadowing next class. We're going to talk about classes and objects. And you'll see finally what all of this means, all class and all static void, all of that will make sense in the next class. But if you enjoyed this video, please leave a like and subscribe. I'll see you in the next one. Peace out. Welcome back to Lesson 7 of the Java Comprehensive Guide. Today we are going to talk about classes and objects. This concept is by far the most core and fundamental concepts of Java. These two concepts make up Java as a whole. Java would not be what it is today without these, so naturally I would say this is probably the most important lesson. All the lessons are important, but if you have, 20 minutes, watch this one, because this one will pretty much change your way of looking at programming forever. In a good way. So Java is designed to be a object-oriented programming language. Now, its paradigm mainly is object-oriented. So today you will learn what that means and how that will improve your programming flow. So let's get started. We're going to go on here to Eclipse. So last time we talked about enumerations, which in a sense are sort of getting into the classes here, but not really. Enumerations have to be constant values, for example, weekdays and weekends, and they must have contain only one value and cannot be changed. So we took a look at how we can do enumerations last class along with stacks. If you don't want to watch this video, please watch that video first, because that video will have some predecessor information on how this all works. But if you are actually a newcomer and you have some prior programming experience, and you want to learn object-oriented programming, well, this lesson is a good place to start. Because the previous lessons I covered all about, the loops, the if statements, those are all basic. But this is what makes Java unique among other programming languages. So let us get started. So remember in the first lesson, I actually showed you what this will mean. I'll tell you in a later tutorial. Well, we're finally here. I am going to tell you what class means. So let us delete this enum here, and we are going to talk about all what this means, including the public static void and, the classes. So let us define a class. So a class is just a class of things. Just don't overthink it. It's like a group of things that you would put together. For example, cars. Let us define a car. So to define a class, all you have to do is type class. And then the name of the class, what do you want to be? I want to name it car. Is convention to name it capitalized. And every preceding word has to be capitalized too. For example, cars made in Germany. So these made in Germany or made in United States or made in Britain, they must be capitalized for the sake of ease of access. You don't have to. You can make it as wonky as possible, but this is hard to read and programmers will not like it. So we'll just name it capitalized. It's called pastel case, but I just call it capitalizing. So that is class. We have a car, and this is the group of cars. It will describe how cars work, but it doesn't actually contain the info for the car. That will be later, which is objects. But let's define a class first. So a class, as like in the main class here, can have pretty much everything you expect it to have. It can have functions, it can have variables, but now that we are in this OOP mindset, these aren't called functions anymore. You must be very surprised to hear that, but we are going to redefine this as methods. From now on, everything related to this, so functions, you want to transition it over and call it methods now. Variables can still stay as variables if they are in the function. But variables outside the function, so variables outside the function, or actually outside the method, because we have already changed here, should be called fields. So they are called fields. So make sure these are in your vocabulary set, because that's what we're going to talk about for the rest of this course. Why? Because it is more intuitive to think about it as a method when you're putting it in the context of a class. Same thing with fields. Think about like a field, like maybe a HTML field. So if you want to just remember this, I'll leave that here. But now that we know, let us define some methods. First, we can define a constructor method. So I'm not going to get too far ahead. Again, this video might be long, but I want you to understand the concepts clearly. So a constructor method contains nothing but the car. So you name it the class name. So you want to type public and then car. Or if you change this to something else, then you type something else here. So you want to type a car. And then let us define a method. So in theory, this is just a method. But if you notice, there isn't any return type. Because usually you would do, like for example, the main function, it returns void. What does the car return? Does it return, for example, void? Not really. It's a constructor. It's special. So that is why we don't have any return type here. So remember that. And also the constructor must be the same. So you'll know that. We can also add some parameters. It is still a method, of course, so let's add some parameters. So for example, we can add its name, the date it was the year it was manufactured. So in year, and let's add its mileage. So you can see where this is going. We're creating a new car with a certain amount of year that's manufactured, the name, and the mileage. So this is I call it the creator, but it's actually called constructor. We want to have proper terminology. So constructor method. So remember this. This is a special method that will create your objects, which we're going to talk about later. But right now, we can add some parameters. And if we take a look, we have the name, year, and mileage. So maybe we want to actually add some attributes like that. Because remember, right now, these are only the parameters of this constructor method. The class doesn't actually have these variables. They're contained in the method. If I don't remember talking about scope, but basically scope, if you remember from back in lesson 4, I believe, the for loops or the if statements, they're contained within in scope. Sorry, that was lesson 3. But for example, if we have this variable, actually let's do a for loop. For int I equals 0, I less than 10, I plus plus. Say we have this here. Will I be accessed out here? Well, let's see. So if we do this system.out.print, we can print I in here. But if we copy and paste outside of the for loop, I will not be defined. See? Eclipse has this little X mark here that says, I can't find I. Why? There's clearly I, but it's defined within this for loop, not the whole function. So same thing with this constructor here. These these variables are called variables because they are in the method. But we want to create some fields. So fields are outside. So to do that, we're just gonna, for the sake of today's video, we're gonna do public, and then we want to define the field with all caps nomenclature. So we will type all caps name. If it has more than one word, we want to do underscore, but all caps name, and then we just want to declare it. We don't want to define anything. So public integer year, public integer mileage. So this will distinguish between a field and a variable. Variables are lowercase, fields are uppercase, just like that. Same thing with the enums. We talked about enums last time. Same thing, uppercase. So now that we have the attributes for the car, we can assign them to the the public fields. So why is this step necessary? Because remember, we can't access year outside of this constructor. So what happens if you have another function, for example, like public speed up? How would that work? You can't access the name, you can't access the year, you can't access the mileage. Actually, for the sake of this example, let's add a speed. So how would that work? Well, this method will guarantee you to access the fields from anywhere. So take a look at this. We can assign this here, and then now in a different function, the name variable will be out of scope, but this field can still go into this function here, or method. So I'm going to show you how to do this. So very simple. You want to call itself by writing this. It's a keyword. As you can see, it's yellow. Just write this. Now what is this referring to? Well, it's referring to the object that we'll create. So let's do this dot name. Remember, this is the class. Dot name equals name, because that's the parameter we're passing in. This dot mileage equals mileage. Actually, yeah, mileage. And this dot year equals year. This dot speed equals speed. And yeah, that's pretty much it. So that constructor method will put everything, the local variables, they're gonna write it back to this field here, and then we can manipulate the fields. So now, how do we do this constructor. So we have the class, we have the car, but how do we put it in here? Because remember, everything has to end up in this main function for it to run. Since lesson 1, I've been telling you that this is the key core component. Everything you ever do in Java will end up running here. Because remember, if this function is empty, whatever you did here, nothing will happen. So let us create an object. So to create an object, remember our enums here. Enums, we type the class name, or actually the enum name, but for this, we'll type the class name. So class name is car, and then let's type a new car called my BMW. So you want to create this new BMW car, and to do that, you want to type car my BMW equals new, the new keyword, and car. Now this is the constructor method, because you can see up here it takes in parameters name, year, mileage, and speed. So let's input some here. Name will be BMW. Alright. And year, it will be manufactured in 2008. Mileage, it will be 15, a new car. And speed, or max speed, I should say. Let's just do speed. Let's go 60 kilometers. So that is how you define a constructor. Now, of course, it says it's not used yet, but we will use it very soon. So if you see, we can actually print some attributes here. And we can just print the car speed by doing this. All you have to do is to type, don't type car, remember. Don't type car, because car is the class. My BMW is what you want to type, because that's the actual car you're referring to. So my BMW dot, let's do name. So you can see we're accessing the car, the field, and now when we run this, it should return BMW. And I'll tell you what everything is going on. So let's see. It says BMW, which that's what we put in. So here's what's going to happen. So when you create this new car here, BMW 2008, 15, and 60 are all getting feed into this constructor method. Again, special constructor method that takes in all of this. You have a bunch of unused fields here that are just waiting to be assigned, and that's what we're doing here. So we're doing this dot name equals name. We're assigning everything here, and then when we get the name, so we do my BMW. Remember, my BMW is class is car, so we're looking into the name field, which you can see it's a string type, and then once we run it, this assigns it to the name, and then boom, we have BMW here. So as expected, if we do my BMW.speed, it will return 60, because the process I described there, constructor writes it to field, prints it back out. So that is 60. Alright. Spend a lot of time on constructors. I know the video is a little bit long, but I want to make sure everything we get in there. So now we get the constructor out of the way. Let's take a look at how we can actually add some more methods, because right now this is a very boring class. It just basically tells you what you put in. How can we modify this? So to modify this, we can add some more methods, right? So that's how everything is modified. So now remember, this method will be a normal method because it's not constructor anymore. So we have to add our return types and stuff, but we're going to return speed. So here's how we're going to do it. We're going to do public integer, because speed is an integer, and then we're going to do speed up. So we are going to speed the car up. And it's going to take in no parameters. Or actually, yeah, no parameters. And then we can define some things here. We can define, actually we don't need to define anything. So we can just do return. Remember from lesson 4, function return type. Return this. Again, our keyword is this, because this is referring to the car class. This dot speed plus equals 5 or 4. That will work too. So what is this doing here? This is telling that we're taking, actually you might not have seen this shorthand, but what this is doing is the equivalent of saying this dot speed equals this dot speed plus 4. So that's shorthand because this is pretty ugly. We can all compress it down to this plus equals. So that's what that is, if you didn't know. So now that you know what this symbol means, you can see what this function is going with. It's taking the current speed, it's adding it by 4, and it's returning it. So when we run this, it will actually speed up by 4. So now the initial speed is 64. When we run it, it will become actually the initial speed is 60. When we run it, it becomes 64. So my BMW, remember, we're calling the object, not the class. So my BMW dot let's see here. We have speed up like that. So this will call the speed up method, and then once we run this, it will return 64. So let us run that, and boom, 64. So that is basically, yeah, that's just a method for you. Now you might wonder what these publics are. That will be covered in the next video, which is all about access modifiers. So if you don't know what access modifiers are, hang in there because we will get to there. Now, right now, this is pretty much the class that we can set up. Now, we can actually also, this isn't really the Java convention for setting up classes. I'll show you why. Because the Java convention, actually Oracle states that you should probably create a new file each time you have a class. So by cramming this, class in here, there's nothing wrong with that, but it's just not that good. So that's why we're gonna create a new file. That way we can organize it better, and so when you hand off your work to other developers, they wouldn't be mad at you for sticking everything into one file. So let us create a new class. Eclipse has this awesome feature where you can create a new class instantaneously. Let's name it class.java, and we will finish. And one thing to note, that whatever the class name is, it has to match the file name. So you can see, right now we will have class.java, but we want to change it to class.car. So one thing we will do is we will rename this to class.car, but you can see there's an error because why? It says file is class.java. So we have to change this. If you look at the top left of my screen, and now car.java, you can see that it has changed the name. So now we define this like so, but here's the deal now. We can't really access this car because one thing, we don't know which file it is. So we'll have to import it. That's where the package system comes useful. So we do import tutorial.car. Now we can access everything in here, and it should work. Now let me see why it's not used here. The type car is already defined. But I don't think so. There we go. And the reason why tutorial.car isn't used is because we're in the same package. It's not unnecessary. So I'll just remove it. But in a different package, you'll have to use import. But I don't know why Eclipse had an error. There clearly wasn't any error. Anyways, so that is how Oracle recommends you to create a class, which is create a new file. That way, if you look at the file, like the file project structure, you can see that is much more organized with the file structure rather than just cramming every single thing into one class. So that is pretty much it. One more thing I will add, kind of foreshadowing next lesson, is you're gonna want to do this. Don't want your name, your fields public for a specific reason. And you might not even know what public means, but you will in the next class, because in the next class we will talk about access modifiers, what it means to have public, private, protected, final. Oh, one more thing. Just add it in today. Final. So final is a special thing. It states it's a constant, just like an enum. Remember our enum here? But final cannot be changed. So we can add a public final. Let's do, what property of the card can't be changed? Let's do color. We can't change the color, right? So we can't change, we can't change the color, so we'll have to define it here. And let's add our data type here. So string color equals red. So this final variable here, if you try to modify it, it will result in an error. Because if you think about it, it's final. Whatever color it is, it's final. No more changing it. So just wanted to add that in there because didn't really find any other place to put it, but final is a constant. Same thing as enums. You cannot change them. They remain this. So color will be red as long as the program exists. So that is a final. Usually finals are good for settings. For example, let's do settings difficulty. So we can do difficulty, and you can change it to like easy. You wouldn't want to change difficulty of a game mid-round, right? So that is basically final, and in fact that is basically class. So once we can also print finals just as how we can print everything else, because it is remember, it's still a field. So we do difficulty. Yep, and then when we run it, you see this is easy. So that is it for today's lesson. Very, very important concepts we need to cover in the next episode. But this episode also very important. We talked about constructors, we talked about fields, we talked about how objects and classes work. In the next few classes, it's all going to be based off of this video. So just remember that. We're going to talk about how you can extend your classes to greater functionality with inheritance and polymorphism. So until then, I hope you stay safe, and I'll see you in the next one. Goodbye. Welcome back to lesson 8 of the Java tutorial series. And today we're going to talk about access modifiers and method overloading. Again, I'm telling you, it's going to get pretty serious pretty quickly, and last class we talked about classes and objects. So as advised, please go watch that one if you haven't, because this is basically no review, because we have a lot to cover today and we have not much time. So yeah, I don't want to keep you for long, so that's why you watch the last video, come back if you haven't, but if you have, great, we'll continue off. In fact, that's what we're going to do right now. We're going to continue off here, and we are going to take a look back at our car class here. So we have our class. Let's just delete this final. It doesn't make any sense. We don't have any difficulty here, but let's just delete this. Alright, so last class we talked about objects and classes, and I told you at the end of the last class, I said that public isn't recommended. Now you don't even know what public is, but today you will. So public, actually, in fact, there's a few of them. So these are access modifiers, and there are a few of them. So access modifiers: public, private, protected. So just like that, we have three access modifiers at our disposal here, and each one of them has their special purpose. So, for example, public. Public is a modifier that basically exposes the variable to everybody. So, also the part of the reason why I want you to define your classes in files is so that these access modifiers will make sense. So think about this file as a compartment. So everything that's labeled public, other files can see. That way it makes much more sense. So think about public class. So you want car, class car. Obviously, public class car, it has to be public because other files can see, our file. But you see the fields there. They're all public too. Now, why do we want private fields and not public fields? So let's step back for a second and let's talk about public fields. So everything again labeled public, you can see outside of this class or file. Let's just call it file because it's easier. So let's go back to main. Now, obviously, we can do my BMW dot mileage. So you can see we can access this because it's public. But if we change this, what was it? Mileage? Yeah, if we change this to private, you can see it no longer exists. Why? Because it's hiding it. So, private, let's see, private, yeah. Alright. And you can see that little red squiggly line underneath that says, I can't find that variable when you can actually find the variable and it's just hiding under here because it's private. So that, now you can kind of see why, what public and private means now. So that's why, again, place your classes in each file. So that way you can visualize this access modifiers better. So if you put everything inside one file, it might seem counterintuitive to have a private field inside, a class that has, it just doesn't make sense. But once you place it inside a file, you can see how it makes sense and how public and private exposes each, piece of data. So now, again, if we recommend, actually not just me, pretty much if you ask every Java developer what they recommend on this subject is that always have private fields and public methods. Well, obviously you're going to have public methods because how else will you access them? So we have public methods. Constructor must be public. Why? Because, you're literally constructing thing. Okay. But everything else here is private. So let us change this to private because it is for good practice. Again, you can see it doesn't require us to change it, but we should change it just because. Not just because here's the reason why. So private members can only be accessible, right, when they are declared using the public keyword. I mean private, sorry. But now why is that? So it's one thing, it's called encapsulation. So encapsulation, it keeps the class increasing from step by step. So it's basically you have like some APIs here, right? And then you want to encapsulate them just to make it abstract, so that when you are when the other when other developers go to you, they don't have to see what fields you have, but they can at least access your public methods, and that's all they have to worry about. Because if you have a bunch of public fields, it gets messy and it's not good. So basically, that's why you want to name it a private, because for example, data hiding are follow to help us programmers write code. So if any class, let's think about it. So if your class can change my field, then wouldn't that mess everything up? Yeah, yeah, it will. It will. So let's, for example, we can redefine this field and we can change it. Now, you don't want to go in and mess around with this field, will you? So that is why you don't want to name it public. So what I'm trying to say, yeah. So all that fancy talk leads down to one thing. You don't want to change what happens in here. You only want to read from it because that's what the purpose of the class is. The purpose of the class is so that you can create abstract methods and stuff so that you can implement them in your main function. So by changing the fields, that defeats the purpose of the constructor because the constructor is literally supposed to change it. So by declaring it private, you cannot change any field. So from main class, you can't access the private member, but in the card class, of course you can access it. It's your own house. I just think about that. If you want to name your field private, it's your own house. Your mailbox will be public. Why? Because other people can see it. So how will we get the mileage then? Well, it seems kind of redundant, but this ensures that no fields are overridden. We just, we just have to do it. We just have to do get speed. And you just have to do this. It seems unnecessary, but it ensures one thing. It ensures you can only read the speed. Or we can do read speed and not write speed. Because if you write the speed, you can change it. I mean, you technically can change it by writing it up here. But this ensures that the logic wouldn't break because everything will have to be accessed through the constructor. So just like that, you can get the speed, and we can do, for example, we can do public string get name, return this dot name. So next time when we do this, we don't really do this. We just do my BMW dot get name. That way you use the method to get the name, and you don't have to write. Don't have to modify the field. This is especially true if you have final variables. For example, final. Remember, we can't change it. So if you have a big project, and you type on Eclipse, and what public final appears because Eclipse has autocomplete and stuff. You might like, okay, well that should be normal. So let's just use it. But then you realize it's a final and it messes everything up. So that's why you want to have some functions so that you can give them what they want through the function without having them to access the fields themselves. So that is why you should have private fields and public methods, because obviously how are you going to access the fields? So that is basically private and public. Now what the heck is protected? Now protected has to do with their package, because you can see we're in this tutorial right now. Tutorial class package contains two classes, but remember, in Java there could be multiple packages. So each package groups a certain amount of classes. So that's exactly what the protected keyword does. So protected, let's just do a final color. So protected final color equals green. Actually, we have to define the variable type. So protected final string color is green. Now, if we access it from the main class, you can see. Give me a second. Let me just put this back. Eclipse messed up on me. There we go. If we do this dot color, you can see that we can access it from this class. So it'll say green here, but yeah. So that's what protected is so that basically you have this package of classes here, right? You have car and main, but you don't really want other packages to see your thing. So it's kind of like a private for packages. So, you can interchange, because I guarantee you, you're gonna have multiple classes, and some of these classes might want to write each other with fields and stuff. So that's what protected does, so that you have this main class, it can look at this protected, but if we create another package and access this color, this variable color, then it wouldn't work. Because why? Again, protected is only for packages. So private, class only, protected, package only. So just think about that, and you'll be good to go. So now we are going to also talk about the static keyword, because look at here. Again, I promise I'll talk about it. Static keyword, nothing to do with access modifiers, but again, one of those things where don't really have anywhere to plug it. So I'm just gonna put it with this. Isn't really worth it to make a video on some, but again, not access modifiers, completely different. Static modifier is a memory management tool. So basically, it allocates memory statically without giving them a dynamic interface. Now that seems like a lot, but what that means is that when you change this to static, you don't have to allocate new memory for it, aka you don't have to do this new car. So let us create a new class. So let's create a new class. Let's do new class here, and let's call it we can call it cat breeds. Actually, yeah, let's just do cat. So cat, and yeah. So obviously this isn't really a good example. You know what, I'm gonna rename it. So I'm gonna rename it to util. Give me a second. Whoop. Did not want that to happen. Alright. Util, rename the file, because from last time, remember the file has to be the same. Yeah. So now we have a util. Now we don't really want to create a utility object, because in here, I'll show you what goes in here. So, you just have the old stuff like add 1 plus 1. Right? This is pretty basic in utility. So that's pretty much what you want. And you don't really want to create an object for this, because this doesn't really make any sense. But you still want to put it in a class, because utilities are really important. These contain your random stuff, for example, like get random number, all of that good stuff, package it into utility. But why would you go through the pain of creating an object just to access 1 plus 1? It just doesn't make any sense. So we do one thing. We type public static int. Again, public static int. And now we don't have to create an object. I know, crazy. You can see no errors. Why? Because statically allocated, you don't have to create. You don't have to allocate new memory blocks. Again, no new constructors. Obviously, it'll print out 2, but just to show that it works, and just to show that it doesn't work for the car object, so we can do we can do my BMW dot speed, right? But we can't do car dot speed. Why? Because remember, car is pretty much a template for you to use. A car, it's not static, there's no static methods in here. So we have to create a new object, allocating new memory, so that we can have this object with car properties. So usually, again, for me, utility class, all static, because you just want to get the function as themselves and just just return back the result. But for anything other than that, I recommend don't use static. So that is pretty much it for static. Of course, there's a few more things. We can have a static variable. Again, sort of like the same thing. We can have a static block. A static block is also a thing that can be executed once. Exactly once. So for example, we can have a static block outside of the main function and it'll get executed. What? Yeah, that's right. I just blew your mind today. You thought that only main function can run. But nope. You can, let's just do my speed. Okay. Get speed. So that it doesn't throw any errors. Oh, right. Duh. Not static. So, read speed, right? Alright. So we can do static system dot out dot print line hello, and you can see it's outside of the main function, but it still prints. What? Right? You're like, what? This isn't what you teach me in the first class, right? But that's just how it works, because remember, this main variable is allocated directly, so that when everything goes in here will be created in a new block of memory. But you can also add static keywords so that whatever is in here just runs once. Basically, memory gets allocated and then flushes the stream. Memory block gets deallocated or destroyed. New memory occupies it. So this hello variable, you see this car variable, or my BMW, if we're truly talking about memory here, this my BMW variable, it will get destroyed here. So the moment it gets destroyed here, so when the main function ends, it gets destroyed. But in the scope of this main function, everything works. But in static, if you have the static block, there isn't no variables, because again, everything runs exactly once. You can't really call anything. Statically allocated memory, again, run the thing that you put in here, allocate it, deallocate it, destroy the block instance, and then move on to the next. So that is the static keyword. So your friends might starting to learn Java, probably watching my tutorial series, but they start learning Java and they're like, the Hello World program, that's the shortest they can get. You have to type all this public static void crap, but you tell them, you're like, no, you can get even shorter. You just type static system.out.print line hello world. And your friends, trust me, it'll be amazed, because people have said you can't do one-liner hello world programs in Java. Well, that is true because you have the public class main, but technically this is the closest you can get to a one-liner in Java, which is a static allocation of memory. So enough about static. Let's talk about function overloading. So function overloading, we're starting to get into the mindset of polymorphism here. So that's where we're trying to go with this. But basically, in this car class, we have a bunch of unused. Oh, why did I move it down here? I don't know. Eclipse is being weird today. Alright, so you can see we have some methods already, but we can. Did you know that Java has a feature where you can actually overload a method? Or basically, it's a fancy way of saying you have the same method with the same name. Process that in. So we have this method. For example, in fact, it's probably not a great idea to do it in a class. So let's go back to, let's just remove this. And boom. So that, okay. So it's not I'm just gonna demonstrate it inside this main class here. So right here, we can overload a method. For example, we can do add right? Int A, int B. So pretty simple, pretty simple function here with the integer A and integer B. You just do return A plus B. So this is something I would have done probably way in the early episodes just to demonstrate how it works. In fact, I think I've done it before, but realize that you can duplicate this exactly, but changing the return type and the parameters. So we can do double. So now you have one function with two variants. So you have an add function that can take in an integer or a double. And you can see Eclipse isn't throwing any errors because I have just overloaded this function. So, and Java the compiler will automatically pick up on which you specify by the parameters. That's why you have to change your parameters, because if they're the same parameters, there will be a problem, because Java won't know which one of these you're asking, because you're using the same parameters. So let's do add. For example, Java knows that this add function, right, static, of course, or else we have to create an object, and we don't want to do that. So right now, Java knows that this is the first variant, add, because it's 1 and 2 are both integers. So of course, when we run it, we will get 3. Now we can do 1.5 and 2.35. So again, normally if we didn't have this overloaded function, it will just return, well, let's see here, 1.5 plus, it will return 4. Now here's the reason why. Remember, it's automatically casting the double. Actually, you know what? It doesn't even return anything, because it will just say error. 1.5 is not an integer, 2.5 is not an integer. But since we have this double here, you can see it returns 3.85, and it doesn't do lossy conversion, and it doesn't round down. So again, it truncates it. So if you don't have that decimal here, it will just return 3 because you're casting it to an integer. But with this, we can also do other stuff. So that is function overloading. You can see, very, very useful. And yeah, because right now, again, if I remove this, let's just comment this out for a second. You can see it starts with an error. It says 1.5 is not an integer, right? Because it's a double. But what Java allows us is to have functions with the same name but different parameters. I'll just put that up here. Different param type. That way, Java will know which is which. Because if you think about it, if we change this to integers, right? So we change this to integers, and then let's just do this. Java will know which one to use. You can see duplicate method. So that's basically why the squiggly line is here. If you highlight on this, it says rename method because we have same parameters. So of course we will rename this to actually let's state this double and double. So again, params must change. And once we run it, we get 3 because Java detects, oh, okay, they're using the integer parameter version, which is up here. Add it, and boom, you get 3. So that is pretty much it for today's video. We talked about, access modifiers, static variable, and function overloading. So very, very important stuff. Builds off of the last video, of course. And yeah, so next time we'll probably talk about abstract interfaces, which is, I know, sounds complicated, but it's not. It's not. I promise you, it helps you with your classes. So yeah, so if you enjoyed this video, leave a like, smash that thumbs up, and subscribe, and I will see you in the next one. Welcome back to lesson 9 of the Java tutorial series, and today we are going to talk about abstract interfaces and inheritance. So, this is a continuation of the object-oriented paradigm of Java, which is pretty much most of Java. It's what Java is known for. As I said, if you haven't watched my previous videos, please go watch them. It is very important for you to watch. Starting from lesson 7, if you don't have much time, just start from lesson 7, watch lesson 8, and now pick up at lesson 9 and we'll get started. So we're really going into the details of, object-oriented programming and seeing how we can possibly use its features to the max. So one thing we can do is to inherit methods and abstract everything. So I'm going to show you what that means. So let's go head on over to Eclipse here. So we have this, thing that I set up previously that I just created some files. They're called employee. Whoops, let's remove that. We'll get to there. You'll know what extends means in a second. I was just messing around before I started. But we have employee, salary, which is an abstract class. We're going to get into that today. And yeah, so basically, we're starting from scratch again. We're going to create a few private fields, because remember from last video, private fields are very important. So let's do private integer phone number, private string name, actually all caps, this is convention, and private string address. So we have some basic properties of your employee. You got their phone number, name, and address. Now let's do our constructor here, which is going to be public employee int number, string name, and string address. So our constructor is defined, and we just follow through with this dot address equals address, this dot name equals name, and this dot phone number equals number. So this is just creating the constructor here, and in fact we can add some sanity checks along the way just to make sure everything is working fine. So we can just do a quick little print statement just to let them know, we can do created employee, so employee, with property. Actually, let's not go that far yet. So we can create employee. So that is our constructor, and again we're gonna add print statements along the way just to help us know what everything's going on and how how the compiler deals with everything. So we can actually do another feature here. So let me just copy and paste it. I had this preset ready, which is this here. We can do mail check. So mail check, this will mail whoever it is to the other person, so their address. So mailing check to name, and let's do a comma here, so comma address. Actually, yeah, let's do a colon like that. This is your just a normal method for you, nothing that bad. And we can also do a public let's do another method here, public call int, actually public void call, and then we can do system.out.println and calling, just gonna add that, and calling this dot phone number. So, you can see, actually, we can do this, but let's see. Okay, we're going to get to that later. But you can see we have a few, methods at our disposal. We have some private, private fields because it is good to keep fields private. And we can also, do some other things, but when let's see, when we actually create our employee here, so let's go back to our main class, our public static void. So we're gonna follow through employee. Let's do employee John equals new employee. And well, remember, this is the constructor, so if we take a look at here, it wants number, name, address. So the number will be 1234. Name will be John Doe. And address will be 1234 Main Street. Like that. So now we have instantiated or constructed this new employee called John. We added their credentials in, and now we can actually, for example, we do John dot mail check. Remember, that's one of our methods here is mail check. So it should print mailing a check to John, 1234 blah 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 Main Street, right? So when we run it, you can see that it works. Create employee, of course, it creates employee, mailing a check to John Doe, 1234 Main Street. So that's pretty much review of last time. And now we are going to get on to the abstract class. So the abstract class will be let's change it to employees. So for example, this employee class currently is a normal class, right? Everything's normal, but we're gonna change it. So in fact, we're going to change salary back to a normal class because just have a sudden realization that it doesn't quite make sense to make the salary a abstract class, but it will make sense for the employee to be an abstract class, because if we're talking about inheritance here, you'll see that salary is basically going to inherit employee, not the other way around. It just doesn't work like that. So let's change this to abstract class. And yep, everything should work fine. Nothing changes. Everything is good. Same thing. Now when we run it, let's just run it. You can see it already says there's errors. Let's go back to this X here. You can see we cannot create a constructor in the abstract class. Now that is very, very important because abstract classes are not meant to be, no constructors in there. But what we can do is we can relocate this. Where are we? All right, so let's copy and paste all of this. Just remove the constructor and paste it into the salary class. Of course, naturally we have to name this salary. And right now it's going to give me a bunch of errors because it doesn't know, where all the private fields are and all of that good stuff. So we're just gonna hold that for a second. And now we can see that we need to create some things for us. Most notably, we gotta create some methods in the abstract class so that we can get all of these variables. First of all, we can get public void get number, And let's do return. Actually, we should do integer, should we? Yeah. Return this dot number. Like so. Public int get address. Return. Oh, I am horrible on my type game today. Public string. Yes, public string get address. We do return this dot address. And finally, public string get name will return type string name, and that will be return this dot name. So just like that, we have a few methods to access our private integers, because remember, we can't access them from salary. So we will we'll leave that here for now. But right now, we gotta go back to our main class. You can see we gotta change this to salary. And right now, it's still throwing an error because we haven't done one thing yet. And you can see at the beginning, I kind of gave you a sneak peek here, which is public salary. We got extend our employee. So this is very important because whatever you're extending here, extends, there we go. Whatever you're extending here, this is your parent. So basically, what you want is that employee owns salary. Salary is a subsidiary of employee, not the other way around. So employee is the base class. What this is doing is basically saying salary is an add-on, not the other way around. It's not employee extend salary. That's why. Because that would make sense. You have the salary class and you extend employee. Like, what? That doesn't make any sense. But what it does make sense is you have this employee class and you can extend salary because, a salary is an attribute of an employee, right? So that is basically what this extend keyword does, is that it assigns whatever is after the extends keyword to the parent of the current class. For example, salary. So right now, you just saw that, that is currently a thing. So extend keyword creates that abstractness. Is that even a word? Abstraction. Yes, abstraction out of the employee class. So that is basically it. But you can see right now we still have errors. Why is that? Well, I did this on purpose because you can see that address isn't defined here, right? And we want address to be defined. Well, I'm glad you asked, because let us copy and paste the constructor back. It turns out you can have a constructor, but not in the way you think everything works. So right now this is totally valid. And now just remember that employee is parent of salary. So technically employee owns salary. So let us let's create a new parameter called double salary. So again, this is the salaries constructor. Let's see. Alright. So, salaries constructor, we have abstract type employee constructor. And now we can access all of these variables by using one keyword. So that keyword, of course, is the superscript keyword. So to do that, we will type super, because remember, sub prefix means below, and super prefix means above. So again, employee is parent of salary. If you look at the hierarchy, basically salary inherits employee. So that's where the inheritance of all of this comes from. But basically that's what inheritance is. Basically inheritance as defined, but super is referring to the parent of the salary class. which essentially is basically, you know, the constructor for the employee class. So we feed that in. We feed all those in to the super class. And you can notice this is the equivalent of this constructor class. So we're feeding this in, and just to prove that this is the equivalent, once we run this, you can see that it says created employee. But our salary class also has to be unique, because what this does is it's accessing this constructor class. So that is what is doing. That is what that's doing. So now we can actually define some more classes. Let's just leave that here. And we can, for example, let's do public void set salary, and let's do, actually before we do that, I just want to show you a handy dandy thing that we can do is let us delete all of this for now, because that is basically review from last time about the private and public things. But we can actually add a abstract method. So to do that, we are going to go back to the abstract class. We're going to do public abstract void set salary. I could have just done it in that class, but I decided that I want to do it in this class because the abstract methods are important. So do double salary, and you can see, well, this is weird. You don't have any body here. So there's no body of the abstract method, because the method won't be defined here. It's defined in the child class, which is the salary. So to do that, you can see it's already Eclipse. Again, Eclipse is impatient. It's just saying, you have this abstract method, man. You gotta define it. So that's what we're gonna do. So calm down, Eclipse. We're defining it. So to define it, we want to copy and paste everything you see here, minus the abstract. So we want to just write that public. What was it? Void set salary, double salary. You can see there's no error because automatically it has this little blue arrow. I'm not sure you can see, but it says implement employee.java. So right now, when we click on that, it'll bring us back here to this set salary class. So that is pretty neat feature of Eclipse. I don't know what IDE you're using, but Eclipse at least does that for this, inheritance, So let us actually define some things. So we can do salary. If salary is greater than 0, let's see, we can do 0.0 because it's a double. Salary greater than 0. And one more quick syntactic sugar here. If you don't know what that means, syntactic sugar is basically syntax, but we want to make it look neater. So in fact, Java has this feature where you don't have to put braces around your if statement. You're like, what? Yes, it's true, but it only works for one line. So in this case, we're just going to do return. Actually, let us add a private field here. So private double salary return. Okay, so we can do return this dot salary. But if we do something else, for example, let's do return. Let's not do return. Let's do int a equals 1 plus 1. This wouldn't work because you can see that it only works for one line of code. So this doesn't work. This is the equivalent of this. So basically, if you don't want to put braces over the if statement, just note that make sure that whatever comes next is only one line. Because if you have multiple lines, you just gotta put that brace in here, and then you can just copy and paste, and now everything will work. But right now, let's not go worry too deep in that. Right now, again, we're setting the salary, so we're just doing this dot salary equals salary. So just like that, we're setting the salary, and now we have the salary class. So we can create another method in here called let's do public abstract void. Actually, let's do double get salary. Right, so again, another abstract method. We know the drill. Just copy and paste it in public void, actually public double get salary. And then just like that, you can see that believe, oh right, return value. So you return this dot salary. So now you can see another arrow. We successfully inherited this abstract method, and now we're putting it to work. So that is pretty much it for the abstract side of things. Now we are going to head on over to our main class, because you can see our main class is still broken here. So to do that, we are going to add another thing. So let's get their salary. One more thing is we are going to go back to salary, and we're gonna call set salary. So we're gonna do set salary because we want it just to, all in one package. We have the salary. We're just gonna use it here. So salary, and now it's basically gonna do this for us. In fact, we don't even need to make it public. We can do it private, but we can't do that because we're inheriting from employee. So let's keep it public, or we could just keep it void. But again, we have abstract methods. But if we can remove this, so let's remove all this. So again, no more inheriting. So we can rename this to private. That way it doesn't expose all of this random unnecessary methods, because these actually, yeah, we should change this to public. But right now we have a private set salary because again, the only place that this is accessing is from here, and that's in the class. We don't really need to call the set salary because we're doing it in the constructor. And I'll just show, for example, we're gonna give John a salary of $50.59. Very odd, but hey, it works. So that will get feed into salary. You can see it constructs the employee. It sets the salary to 50.59, but it doesn't require the main function to expose this private set salary thing. So that's basically what we're doing here. And then we can do system.out.println John.get salary, and oh right, we have to change this to salary. And now it should work. You might have noticed this was employee the whole time. Why didn't it throw an error? We're calling this a salary function, but why didn't it throw an error until we got here? Because we didn't have that. Well, my friend, that is a great question, because for the next episode, that's what we're going to talk about. That has to do something with polymorphism, and that is very important, but topic for next time, because we are already a little bit over time. We still have to get to interfaces. So yeah, hang there. The next lesson we'll talk about how, if we change this to employee, you can see it still works. There's no error. Obviously there's an error here because employee doesn't have this method, but there's no error in defining it. So what's going on here? So we'll get to that next time. But once we do this, we will see that it gives some things. We can create employee, and salary will be 50.59. So, I mean, that's pretty much it. And then, of course, we have this call function. But, okay, so this call function here, we're going to put it to use because we're going to create a new thing called an interface. So, interface achieves total abstraction. Basically, everything is abstract classes. I'll show you what it means. So, let's create a new interface. And then, convention for interface is right before what your class name is, you wanna type it I. So I employee. So we're creating an employee interface. We just want to name it I employee. So let's do finish. We have this lovely interface called I employee because we're letting people know that this is an interface, and we can achieve total abstraction by doing the following. So we'll put these two methods to use because right now they're not really, in use. So let us do this by doing public void mail check public void call. So you can see total abstraction. We don't need the abstract thing here. We don't need this because it's unnecessary. We already are achieving abstraction. So obviously Java wouldn't really care if you put this here, but why put it there when you can just do this? Save time and energy, and basically this is the equivalent of a interface. Again, this is redundant. Interface already abstract, so it's kind of like saying, I'm burning on fire. Burning what you're already burning. Yeah, you're on fire. So that's basically it for interface. Nothing else, just the declaration. If you have parameters, you can add stuff in here, like int double. Actually, no, why did I name it double? Alright, we can do int, like int num. But right now, we don't need that because we are going to go back here. You can see we have these exact same methods, but we want to implement this interface. Now, the key word, I just said it, is implement. So we can do two things here. We can either implement an employee or salary. Let's do employee. Implement. Implements I employee. There we go. Again, add that S because or else I spelled it wrong. And now we can see that it's taking whatever in here, and now we got to add this annotation. So you just do the add symbol override. So we're telling Java that we're overriding it, and yeah, this is actually optional because we don't really have anything in the interface. So I will recommend you not to add override because that is just redundant and useless. So you can see it already it extends this functionality. Now you might ask, well, interfaces are pretty boring if you ask me, because like what even are they for? Well, here's the deal. When you're working with APIs, it's nice to have everything in a nice orderly interface, and that's exactly what it is. It's an interface. Think about user interfaces. They're meant for ease of access. Same thing with this. They're meant for ease of access for developers. And that's the reason why when you're writing source code, think of this as like a header file. If you ever script in C++ or C, you will know that header file doesn't really contain any doesn't really contain any content. It just contains, declarations. So that's why we use interfaces. And I'll show you a primary example of overriding, because that overriding annotation is very important. So we're gonna override this mail check function in salary. All we have to do is we're gonna copy that over, public void mail check, and what was the parameters? Mail check, oh right, void. Alright, no parameters. and it's gonna do system.out. Let's do that. Copy that over. But we have to alter something. Let us alter this thing. So again, we don't have this.name. What is this.name? It's nothing, right? So we have to do super, right? Hello, why is this blue? Should be orange. Super dot get class. Actually, I probably shouldn't use this method. Let's do super. Let's see if we can get the name from here. Oh right, we're having a issue with the private field. So let's just write the quick function again. Public void string get name. Totally forgot about that. So we do return this dot get name. No, we are not doing recursion. Return this dot get name, and then once we go back to our, what was it? Salary. Yes, we do, instead of doing super, we do super dot get name. Again, super is just referring to employee, so that's what. Yeah, there we go. Okay, and then we can do super. We can do salary. You can see we changed it because originally it says address, but now when we do mail check, we're instead of telling them the address, we're telling them the salary. So do that. On top of this, we will now add the override function. So we will now add override, and now everything should work. So once we run mail check, we can do john.mailcheck, and it will say well, it'll say mail to John and then 50.59 something. So yeah, you can see mailing a check to John Doe, $50.59, because we overridden the other thing, Majiggy. Where was it? Yes, back here we overrided this mail check, and yeah, so that is pretty much it for abstract classes and interfaces. So one more thing about interfaces is that you can actually make them a declarator. I'll show you what I mean. So basically, we can change this. Yeah, where are we? We can change this to employee. So employee. You can see, obviously, we don't have any get salary method, but just to let you notice that interfaces can also be a declarator type, just like so. Of course, since salary, let's actually do this just so that we can see it works. We can do public void get salary, and then when we go back here, let's change this to public. Oh right, double. Whoops. Public double. Public double. So interfaces work exactly like classes, but they pretty much have nothing in them. So we change the public double, and then we wanna do. Okay, so you can see we don't even have to implement it, because we can do implement employee, right? But that's redundant because we extended the employee class, and if we go to the employee class implements interface. So you can see it automatically adds that little arrow for us, because again, everything in the employee class gets copied over here, and you can see that we don't need to write implement employee, but just so that you can see what's going on behind the scenes, it is actually implementing employee, because employee, the interface, sorry. So that is basically it. So when we run this, you can see get salary works because John isn't a John isn't a John isn't a salary employee object anymore. He's an employee interface, which of course basically John has all these methods at his disposal, but John doesn't have this call method because the call method is not within the interface. So if we do John.call, I think naturally it will throw error. You can see, you got, wait a minute. I guess you can, get what, I guess you can't get what it implements. I didn't know that because I thought that when if call isn't defined here, it is defined here. Oh my god, I am so dumb. All right, let's find the thing that isn't defined. So just to show you, because I thought I was tripping because John.getName. There we go. There we go. You can see that getName does not have, it doesn't exist. Well, it clearly exists in employee, but it doesn't exist in the interface. That's why. Yeah, for a second I was like, wait a minute, does it really get the method from the implementing class? But nope, my memory is correct. It's just that when I do John.call, it's actually defined here. So, quick recap, we basically learned about abstract classes and interfaces, and just like that last last thing over there, we can actually take a look. You can see John.call, once we run it, it works because we have call method, but John.getName doesn't work because the interface does not allow that. employee John can create a new salary interface because the salary implements the interface. It also extends the employee, which is the parent class of the salary, also an abstract one, that basically uses the super keyword for the constructor of the parent class. So next time, we are going to talk about polymorphism, because remember, what we did here, we're slowly foreshadowing polymorphism, but right now, you can see it is possible for us to have a different decorator type than a constructor method. Obviously, salary and employee are different. Next time, we are going to see how we can make this possible. So, we'll see that. And yeah, that will be it for today's video. If you enjoyed this video, please leave a like and subscribe. And stay tuned for the next one. And stay safe out there. I'll see you next time. Peace out. Welcome back to lesson 10 of the Java tutorial series, and today we're going to cover polymorphism. Now this is probably going to be the shortest video of the series. Despite the long and complicated name of polymorphism, actually the functionality of this is actually very simple. And on the plus side, we did all the heavy lifting in lesson 9, aka the previous episode, where I spent about 40 minutes talking about abstraction, interfaces, and inheritance. So basically, this is just a little neat tool, basically just served as an add-on of lesson 9. So without further ado, let's just get straight into Eclipse here. Again, super short tutorial, just let you know that there's this advanced feature called runtime polymorphism. So we're gonna head over. Alright, we just have a blank canvas. Again, we're kind of back to square one here. Just have that comment reminding you that from now on we're going to call them methods instead of functions, and fields instead of variables. So basically, we are going to define all our classes inside this one main function because it's, again, super short, super sweet. So we're going to talk about runtime polymorphism. It is also known as dynamic method dispatch. It's basically a process in which a function called to the overridden method is dissolved at runtime. So this polymorphism is achieved by overriding the method. So remember that annotation last class we talked about that annotation where we did the at override. Yeah, that's gonna come into play here. So let us create a class here. So we're just gonna create a short and simple class called class parent. So let's do class parent, and we can do void. Since there's no public or private, we're in the same file. It doesn't matter. We don't need private or public or all of that. So we just do void print, and it says print system.out.print line. And let's see, what should we print in this class? We can just do, just print its name. Let's just do parent class. Again, this is all very simple. You should know how all of this works. So we can do class child1. Now child1 void print system.out.print line. We're just doing some setup work here, and not actually going into any polymorphism yet. We're just setting up our classes, making sure everything is working. So obviously we have to do the extends, because I will say right now, the extends keyword does work for non-abstract classes. So last class we talked about abstract methods and classes, but you realize that extends can also work for pretty much any single class. Abstract classes are just for abstraction, but if you can see, we have this green triangle which tells you that it overrides this, or we can add this override. Again, it doesn't really do anything, but it's a comment. It's basically saying that, you tell the developers you're working with that this method is overridden. You can see it has the same tint, same color as the comment, because that's all it is. It's just an annotation. It doesn't actually do anything. But I'll put that there so that other people will know what you're overriding. So that's why you put that there. Class child 2 extends parent. Again, parent can be totally an abstract method, but we can also make it a normal method too. So override, and then we do void print system.out.print print line child 2. So we have both methods here. Both of them are overriding. Now let's actually do some polymorphism here by creating some objects. So we can actually create this object called parent. So let's just declare. So parent object. Alright. Now we can reassign the object to be a new subclass. So we can do, first of all, let us do object.print, and put that over here. You can see, got initialize it to equals new parent. There we go. And now once we run it, you can see we have parent class, because that's just the default parent class. Now we can actually change parent object to new child 1, and it will still work. Now this is polymorphism, because polymorphism literally comes from the word meaning multiple forms. Because if you remember morph, you can morph means forms. You can morph into like objects and stuff. Morph, and poly is the Greek prefix for multi. So multiple, morphing, multiple forms, and same thing with here. This object can take on multiple forms. In fact, it can take on child 1, and once we run it, you can see it's child 1 class. And you're like, what is going on here? Well, remember from the last class, I promised I would tell you Because last class we did the thing with the employee and the salary, yeah. So this is basically the same thing. Because usually you're used from lesson 7 to define like this, which is also absolutely 100% valid. But you can see that we can also do it like this. But this will be wrong because child 1 does not implement child 2. But if we do child 1 extends child 2, so let's just do child 2. And now, class body. Let me see. Oh, right. We have to put this up here because it's not defined yet. Can you extend both classes? I don't think so. All right. So, anyways, as I was saying, you can do this, and it wouldn't work because type mismatch. You can't convert child 1, child 2. But what you can convert is from parent to child 1 because it's overriding whatever it is in parent. So basically, again, I'm talking about inheritance. Polymorphism goes all the way back to inheritance. Think of child 1 inheriting parent's genes. So the object is of parent 1's class, but it can take on the form of child 1 or 2. Because if we run 2, you can see that prints child 2 because basically what it's happening is the parent's gene, just that plain old void print. Then the child gene overrides the parent gene, and then it does child 1, but it extends parents. Again, the keywords is extends. So that is pretty much it for polymorphism. So again, this seems pretty much like a review of last time, which was all about the interfaces and stuff. So if we can get like an interface here, so we can do interface interface ancestor. So you can see that, let's say we have an ancestor interface, and our ancestor interface is void print. So you can see the parent will get its function from the ancestor class. So interface, I mean. So we can do implement ancestor like so, and you can see change this to public because the interface. Yeah, so I'm just gonna change everything public because, you know, the interface is making it public. So, but naturally, again, implements, extends, same thing. Implements just a version of the interface. You can see if we change this, everything is inherited from the ancestor interface. So we do ancestor object equals new child 2, and it still works because if you look at that, child 2 overriding, let me just reformat this real quick, overriding parent, and parent is implementing this empty function called print from ancestor. So that, again, very similar to last class. Again, you might think it's pretty redundant, but nope, there's a few little differences, especially with the child and parent and the implementing. But from last class, you'll see that this is actually polymorphism in action. Last class, we did this interface object equals new class sort of ordeal. But in this class, you will know that you can also make it the class of one class the declarator of a new constructor of another class. Pretty confusing, huh? But not really. If you take a look at the code, everything will make sense. So you can see, again, object's parent, object takes parent class, but it actually overrides it with the child constructor. So that is pretty much polymorphism in a nutshell. And if you enjoyed this video, please leave a like and subscribe, and I will see you in the next one. Welcome back to lesson 11 of the Java Comprehensive Guide, and today we are going to talk about generics and exceptions. So we are covering the last bit of object-oriented programming with generics and exceptions. I should have covered beforehand, but there isn't really any appropriate place to put it. So I'm going to put it with lesson 11. Well, we're almost done with the series. We only have 2 more lessons left, and those are all useful libraries you can use. So technically, this lesson is the last lesson regarding the core features of the language, and everything else is libraries that I personally use that will simplify your coding very much. So let us go back to Eclipse here. So this is from last time we talked about polymorphism. And you can see we have this throws no such field exception and security exception. So what is exceptions? Well, exceptions, let me just remove all of this for now. Exceptions occur when basically the Java compiler does not know what to do. So basically you have to handle these exceptions because obviously exceptions will occur. So they occur like, very often in your program, and if you do not know how to handle these exceptions, you could potentially be in big trouble. So today I'm going to teach you how to handle exceptions in Java. So the most common way to handle exceptions is to use try-catch exception. So to do that, we will we'll create a new array. So let's do int num, and then we can do let's see here, we can do int my numbers or num equals int num equals 10. So actually let's do 1 2 3 elements. We talked about this in lesson 4, and let us do this is like the most basic type of exception. Usually, you don't know what type of exception a function throws if you look at the API or the Java doc, which I also talked about in lesson 4. It's what this is, the Java doc. Yeah. So basically, we are going to get the 44th element of number. Well, you can see obviously it'll throw an error because there's not 44 elements. There's only 3. So once we run it, you can see Java throws this exception called array index out of bounds exception. So that is this exception. So that's pretty much the most basic exception I can simulate right now. Of course, there are many other exceptions. For example, logging credential exceptions, security exceptions, like, other exception stuffs. But we are going to just simulate this exception because, because we can just do that. So basically, we can also remedy this because, we want this code to basically not error out, because this looks bad. What does this even mean? Like, why? So we can counter that by using a try-catch statement. I'll show you what I mean. So we want to try this code, which obviously wouldn't work, but we're going to basically catch this exception, which is array index out of bound. You have to type the full exception. Believe that I typed that right. Alright, and then we can name that variable anything. I can do it FG, or I can do exception, or except anything, but E is a traditional norm. Just like, don't ask why for loops always start with I. It's just how it is. So we can do that instead of making it print the ugly index out of bounds. We can make Java actually print, for example, array is out of bounds, which looks much clearer than exception in thread main java.line.array index out of bounds exception index 44 out of bounds for line 3. Well, I mean, that is pretty, specific, but say like we do that, once we run it, you can see array is out of bounds because it tries this code and it says, okay, we have an exception, let's catch this exception, and then we'll print. Okay, what happens after you catch the exception? That is what you print. So that is pretty much try and catch exceptions. One more thing for exceptions is that you can create a custom exception. Now here's how we do it. So basically, Java has these exception types. Now these exception types can be you know, they can be used to our advantage. And to do that, we'll create a new function called, let's do public, actually, let's just do void is adult. And we'll check the age. Obviously, in the United States and some other countries, the age of a legal adult is 18. So we will say, if age greater than 18, we do, or greater than equal to, because 18 also constitutes as, alright, we do system the print line, we do you are an adult, so like so. And then if it doesn't work, so we just add an else statement, else we throw, yes, we can throw an exception, custom exception, but not custom type, because there are exception types in Java. Most notably, since this has to do with a number, we do throw arithmetic. How do I spell arithmetic? Let's see. Arithmetic exception. There we go. And I think we do that and then pass it in. You are not old enough. So just like that, I believe, since this is a custom Java type, you can see Eclipse is throwing an error because I think we have to, since it's a custom type, we have to construct it with a new keyword. So let's do new. There we go. Throw. We got, it's a custom constructor. Throw new arithmetic exception. You are not old enough. And once we run it, let's see. Let's delete all of this, and we will do. It should be boolean because, but let's just rename this. This is bad naming. It's not. Yeah, there we go. Check adult. So we can check adult, and then we can do 23. There we go. 23. And alright. Sorry about that. Gotta make that static. If you don't know what that means, watch my previous tutorial on why this will work and this wouldn't work. So yeah, go watch that. But yeah, and then we do you are an adult, which perfectly fine, everything fine. But we can basically crash the program. Not really. We create a custom error, which is if we change this to 13 or 12, you can see obviously this person is not an adult. So you can see we created our own custom exception called you are not old enough. Now, obviously, what type of exception is that? Well, you can see it is an arithmetic exception because we're doing a comparison. And we can specify some notes here. So this is the note. It's saying, alright, basically Java detected something wrong with your math. What's the math wrong? You are not old enough because your age is under 18. So that is exceptions in a nutshell. Very, very, very simple. That's why I decided to do it in a previous video. But, I think now is the appropriate time to do it because next we will be covering something else. But that is exceptions. You can throw exceptions. You can catch them. All of that good stuff. Alright, make sure you catch all your exceptions. It is not good practice just to leave them hanging there. So, next we are going to talk about generic methods. Now, put back your thinking, your OOP thinking cap again. And we will talk about generic methods, which is probably a very useful method for anything pretty much, because it allows you to specify the input type. I'll show you what I mean. So let us create this new function called static, and usually we can do stuff like int, add, right? That is a return type. We can also do static string add, also a good return type. We can do also, I don't know, a lot of things. Static double, static void, not return anything. But do you know that you can make the user or the caller specify their own return type? Yes. using exceptions. I mean, not exceptions. Sorry, using generics. Yes, I'm still in that exception mindset. Alright, so using generics, we can create our own custom type method. All we gotta do is we gotta do this little angle bracket thing, right? And then anything inside. Usually we put E. Why? I don't know. It's just a convention people made up. Just like, again, I'm just telling you, why are we doing for I and not for not for J or for K? Well, I mean, we do, but that's for nested loops. But why not for X, right? It's just how it is. But keep in mind, this can be anything. So you can be elephant, right? That will work, but that's just not descriptive. So we just use E. So just like that, that's how you declare generic. And of course, you have to do your return type, which is, again, this specifies the parameter, not the return type. So we have to do our little return type here, which is going to be void for this demonstration. So we'll do void, and then we can do something like very generic as print array, because let's be honest, arrays can take in all sizes and shapes and all different formats. So basically that is a very good application of this function here, because arrays, again, they can take in pretty much everything. Now here's where it gets interesting, because if you look at the parameter, we will have to specify whatever it is in E. Again, E will be our type. This is our parameter type, our return type. So our parameter type will be E array. So what did I just do here? Because if you think about it, if we change this to integer, right? Of course, Eclipse is messing up, but we change this to integer, and then we do this to integer array, right? Actually, let's remove that. Right? You see that everything works fine. But if we, same thing, all we have to do is just replace whatever this is. Again, we're letting the user define their own types. So we can just use this, and whatever E is, replace that. For example, if you want an integer array past that, E will be integer, and you have int. So literally just erase E and put int here, right? That's just that. That's just what it means. So that's why we do this, so that you can see it can be used for many different types and not just one type. And now you just do a basic, for each loop. Everyone knows what this means. For, again, E, again, has to relate with the parameter type. For E element in array, right, we print that and then use our syntactic sugar. If it's one line of code, we do not need to print using the curly braces. So now we do printf because we are formatting. Again, printf is a format function. Print line is not a format function. So we do printf, and then there are some escape string literals, all of that. I'm not going to teach that. There is a whole array online. Just search up string formatting, symbol, special characters, along those lines. But I'm going to use %s to format our array here. So let's do element like that, and now it will format all the elements, and at the end, let's make sure it prints actually to a line. So we do system.out.println with nothing inside, and there you go. So that is our generic function. Looks pretty weird if you think about it, but if you take a look closely, you can see that it is not weird at all. So let us see how we can call this function. Again, I specified that user can define their own function. So let's bring our numbers thing back, which is going to be 1, 2, 3, 4, 5. So 5 number array here, and then let's call this function. So to do that, we want to do print array. We specify the type. That, again, this is our E here, equivalent of E, and then we want to now do the parameter type, which is num. So just like that, we have created our generic function. Let me make sure what this is doing. Print array. Let's see if Eclipse is just bugging out, because I don't know why it isn't working. Whoa. That is the reason why, because we can't actually do this. We have to do a... that is weird, because when we see, we can... Oh! That is the reason why, because we gonna need to use this integer. Let's remove this. I think this will work. Okay, but that's not what I want here. Alright, let us debug and see why this is not working. Because last time... Oh, you know what? I think it might be because integer is a primitive type and you can't do that. You have to use the non-primitive type. Print array cannot be resolved. Well, let's figure this out together. So, you can see that this is very strict. Alright, so I know what the problem is. We can't cast primitive types, so I have to do it like that. But okay, let's retype this. I think it's bugged out. So basically, we can't pass primitive types to print array. Now it works. Yes, finally. Okay, should have known that, but I forgot. You cannot pass your primitive. So anything with the orange color. So you can do int. No, you can't pass that. Double. No, can't pass that either. Char. No. Well, how would you pass a double then? Well, you had to write it out. I know but it's the way it is. So that is how you do. That is how you define. Now, see, you can see everything works fine. Of course, one isn't a double, so let's do that. There we go. You can see we have, when we're doing generics, we can't use the orange keyword, aka primitive types. We have to use the counterpart, which is this integer here, and that is how we do it. So once we run this, now it should work. So again, do not use primitive types. Only use this non-primitive type for it to work. So obviously string will work because it's not a char. So you can see in the bottom it actually printed, so nothing's wrong with my code other than that. But you can see what we are doing with the array. Now we can see that, remember in lesson 5 array list sound pretty familiar, because array list, to do that we do, of course we're not including, but we have to do new array list, right? Array list integer, and then new constructor. Well, doesn't that look familiar? Because if you take a look at that, we got angle brackets. In fact, array list, it's just a giant generic function. So once we import array list, let's see if we can go to the array list where it's defined, and I'm gonna try to open the source code for it, and let's see if our inference is correct. So I hypothesize that array list is a giant generic function. So let us go to this array list. So we go to Java System Library. We go to utility. So we do java.base Java utility and array list. Alright, and now we just have to find the constructor, and would you look at that. So, this is the abstract class, but we gotta find the constructor. This is the actual constructor. So you can see, we have some other stuff like collections. Collections, again, talked about in lesson 6, how collections that sort. But you can see we have this E here, which looks not too different from our generic function. And in fact, it is a generic method because we have this declaration of the generic up here. So, yeah, it is pretty cool to see, you know, basically we have source code of the Java. So, and when you look at that, we also have this, you know, they throw illegal argument exception, right? We just threw arithmetic exception. But it's really cool if you go in your Java system library and just take a look at what the actual system, you know, core files are doing. Because once you like watch this, you'll see that most of these you can make out. Cause for example, this one, look, static, that bracket E, element at, same thing with here, we got static E, and now of course they return element E, but we return void, which is different. You know, we have void, but you can see the gist of it is the same. Now we have, of course, some other, hard stuff that obviously we're not qualified to do, or else we'd be working at Oracle. But I'm just saying, if you want to know, if you want to see how good you are from, for example, how good you are at Java, I suggest taking a look at one of these methods and making out what's going on. For example, I'm just going to scroll to a random method. I'm just going to find a method. For example, let us take a look at this method here, list iterator. So I don't know what it does. Of course, it tells you up here, but let us see what's actually doing. So already I see that we have this return type as another class. So if I guarantee you this is another list iterator somewhere. Yep, it's down here somewhere. List iterator, right here. It's an interface. So interface takes in a generic, and then we have the name. It takes in an index. Obviously, range check for add. This is another function. So let's try to go here if we can, and you can see we go down here. Now this is in this illegal argument exception class. Remember our super. This definitely inherits something. It inherits runtime exception. So that's basically. I'm not gonna go too deep, but you can see we just dissecting list iterator, and boom, we have done it with our knowledge of object-oriented programming and generics. So again, as we're getting to the end of this series, I highly suggest open up one of your source code. You know, you'll be using like HashMap. We talked about HashMap. You'll be using HashMap all the time, but what does it actually mean? So you can just scroll down here. Of course, there's a bunch of documentation for you to use, but look at this. What does this mean? You see a bunch of if statements. You already see there's some, parameterized type. Again, this is probably your interface. We have some generics up in here defining some other classes. You can actually trace them, and once you're able to explain what this means, you're pretty much set. Of course, I'm not expecting you to actually create this, or else you create your own programming language. But if you can explain to other people what Java source code is, you definitely are qualified for the job. So that is it for today's lesson. I'm just gonna run again so that you can see that that's how generic works. We talked about exceptions and generics, and when you look at that, we are almost done with the series. We're done with all core language features. Next class, we're going to talk about input and output streams. Very useful if you're writing to files and all the other junk and taking input from users. And then, yeah, we pretty much have 2 lessons after this. So if you enjoyed this video, please leave a like and subscribe, and I'll see you in the next one. What is going on, guys? Welcome back to lesson 12 of the tutorial series. This is the second to last episode. which is very good because the next episode we'll talk about useful libraries. So yeah, that's pretty much it. This is the last part of Java that you must know. Well, you don't have to know it, but it will be good to know. This is the last part. So let us get straight on into the video. So right now I'm starting from scratch again. You can see I have the main function. That's pretty much it. This seems like it is kind of like lesson 1, but that's because I cleared everything out because you're gonna need to know everything that I taught in the last lesson. But it's good to know, but not required. So let us go and create our first type of input-output stream. Now that sounds complicated, but it's actually not. Input-output stream is basically just how you read input from a user. Now, let us take a look at how you can read input from the user using console. So to do that, we will import our own, actually not our own, but Java's own library called scanner. So to do that, we do java.utility.scanner, just like so. And then you'll see, of course, Eclipse complains that it's not used. But to define a scanner, remember back to our lesson 7 class, how do we define a scanner? Well, a scanner is an object. So naturally, if I am you, I would do this. So this is basically how you define an object. If you remember to object like in lesson 7. So now now remember that this new feature, this is a constructor. So a constructor can take methods. It can take parameters. So we can, in fact, scanner requires a parameter called system.in. That is your console. So system.in is your console input, and system.out is your console output. So next what we're going to do is we are going to actually take some input. So to do that, we are going to create a new variable, preferably string, because that's what you're going to input. And then let us do something like, for example, we can do string input just as a generic variable. And we do our object that we created. So my scanner dot next line. So this will take the next line. Now we can get the input. For example, we can just write something on here. So we do system.out.println. What is your favorite color, right? So we do that, and then the next line we do system.out.println. Cool. My favorite color is also, and then we concatenate that with the input. So just like that, that is how you define an input for scanner. So let's run this and let's see if it works. So you can see what is my favorite color. Let's just say green. Cool, my favorite color is also green. This can work for anything you type. Just make sure I'm not doing anything behind the scenes. So what is favorite color? I can just spam random numbers, and it also outputs random letters. So that is basically it for input. You just save it to a string, and then you can do whatever you want with that string. So now we're going to talk about how we can, you see, I know you saw in the corner of your eye this example text document. Now, of course, it has nothing in it, but that's for a reason. Because next, we're going to talk about how you can modify files. Yes, it can also work for files, not just console input and output. I'm going to show you how we can write, our favorite color to the file. So, but first, you can see that it's throwing an error because we never closed the scanner. So to do that, we just do myscanner.close, and then everything will work. So that is how you do that. So next we are going to talk about file IO. So now let's try to modify this file. So to do that, let us do this. So we just import some new library. So we do java.io because, well, the input output, that's the name of this video. So file writer. So
we are writing to a file, aka the example file, and then we have to import this Java. I believe it is IO inside IO, but it is java.io.io exception. So we have to import. Remember from last class, we imported the exception to handle errors because we don't want errors existing in our code. So to write to a file, it's basically the same thing. But since you saw that IO exception that I imported, you already know what's coming. And so we have to do this try and catch statement just to make sure that it works. So we do try, and then we do define a new object. So file writer, write equals new file writer, and then it takes the input of the text file. So, or any file to say. So our text file is called example.txt. So we just do example.txt, just the name of it, and make sure it is in your directory, just like so. You can see everything works pretty good. Now, just like the scanner, we have some methods we can do. So we can do write. Actually, that's probably not a good idea. So my writer dot write, and then we can write, for example, input, because that's our string, and there we go, just like that. Make sure, I don't think anything's wrong. Eclipse is probably, oh right, and then we have to catch the exception. So catch IO exception E, and then we define, we do our catch here. So we can do, like, we can just copy and paste this. We can say cannot write to file. So that's pretty much what we handle, how we handle exceptions. Cannot write to file. So just like that, that is how you do a file stream. So now, if we run this, do you think it will work? Well, I'm glad you said no, because we forgot to close the stream. So to do that, we again follow through my writer, not close. That way the file will be closed, it will be sealed just like a package, it will be sealed, and then it will be shipped off. So that is how we do it. Let us run this program. So it'll ask us, remember, we have this up here, what is your favorite color? Let's say blue. Cool, my favorite color is also blue, and we check to the example, you can see that something is not correct because we have forgotten something very, very important. So you might ask, what is that important, thing that we forgot? Well, the thing is, we have to change this directory to point to the file name. So you might ask, how will we do that? Well, let us see. So we can see that let's see what's wrong with this code, because debugging is always used. Even I sometimes debug. So I assume that the problem is we didn't close our scanner. So let us try that. So let's close it, and let us see if it works now, because if it doesn't, we can try something else. So let us type blue, and let's see, maybe it's not example.txt. Let's rename this to example.txt. Maybe that's why. Yeah, now it's example.txt. Maybe that's why. So I thought Eclipse automatically did the text thing, but let us find out. Blue. And alright, so that has nothing to do with the name. But then again, we do not have cannot write to file either. So that means the exception's also not hit. So what do we do now? Well, I'm glad you asked, because I was thinking of not, okay, so we add some breakpoints and see if it works. So breakpoints are good for debugging. You can see that little breakpoint, once we run it, it will hit it, and then it will tell us what is wrong with our code. So you can see that our breakpoint never got hit, which means that this block of code is not running. So let us try to find out why that is the case. So let us try to find out. I'm going to give you a few seconds because I already see the problem. So it turns out that I forgot to put this flush because the flush is very useful for flushing the stream, which means clearing out all the garbage before so that the new text can go into the actual file. So now you can see my favorite color, cool, my favorite color is also blue, and cool, my favorite color is also blue. So that is how you write to a file. So that is it for today's lesson. If you enjoyed this video, leave a like and subscribe. Again, we are so close to being done with this series. Next class will be the last class. I'll show you a bunch of little libraries that I use. Not really any new content per se. These are optional libraries. But again, if you enjoyed this video, please leave a like and subscribe. I'll see you in the next one. Hello everyone, welcome back to lesson 13 of the Java tutorial series. And guess what? Today's the day. It is the last lesson of the series. We are almost done. After this video, I would say you will have a solid understanding of Java, if not even more. I can't guarantee you a job or any career position, but what I can guarantee you is your Java skills will be significantly better from day one. I assume that you started without knowing anything with Java. Hopefully you learned something, and I want to take this last lesson to actually take a look at some useful libraries, because these libraries are very underrated. They don't get enough attention, but they're, again, very useful either for debugging or just some utility libraries that I personally use. So I want to spend the last lesson looking at these. Hopefully you'll learn some useful libraries yourself. It's going to be a laid back episode. It's not going to be like what lesson 7, 8, or 9 where it's like hardcore OOP, you know, none of that. It's just going to be laid back. We're just going to talk about some libraries and then we're going to sign it off. So congratulations, you make it this far. Once you finish this video, you will be officially a Java developer. Well, at least on the path to a Java developer. Alright, let us go to Eclipse. So we are in Eclipse. This is from last time we talked about I/O exceptions and file reading and writing. But let us remove all of this because we are first going to talk about probably the most useful / underrated library, which is the random library. Sometimes you just gotta give yourself a random library just because you want to create a random number generator or do something with like C and stuff. So let us do a random number generator. So to do that, let us set our context first, you know, random number generator. So it looks like we can create a new object. Again, random, my random equals new random. So again, from the previous slides, I mean not the previous slide, sorry, the previous episodes, from the previous episodes, you can see that this is a Java constructor. So that is how you create your own random object. Yes, not a class, because they created the class, we create the object. So there are a few things we can do here. Most notably, we can do next int, and next int. All that does is it'll print out a random number or a pseudo random number, because there's no true randomness. You should check a theoretical computer scientist with that, but there isn't any true randomness. I'm not gonna go into detail, but basically they take noise from a seed, and that's how they get your random numbers. So to do that, we can do next int, and then we can set a max bound, or we don't have to. So we can do max bound. For example, we can do all numbers from 0 to 49 inclusive, or we don't have to do one. So for example, we can just run this. So let's run this, and you can see it generates every available int. So again, from lesson 2, when we talk about data types, integers can go super big. And obviously this number is pretty big. But if we set a bound, let's generate a number between 1 and 50, you can see that it generates 8 because we set a bound for it. Look, super easy, I promise. Alright, so that is pretty much the random number generator. You can do a guessing game by combining it with the scanner. So all you have to do is do java.utility.scanner, take the user's input, so you can do scanner equals new scanner system.in, right? And then you can take input as, guess the number. If the number is greater than, say, the number is less than or something. So that is how you can do a random number guesser game. And yeah, so that is our first library. Second library we're going to talk about is going to be the Java datetime library. So sometimes you would just need to use the current date or time of the year in your project, because whether it's clock synchronization or whatever you need, datetime is always a good format. So to do that, we will import java.utility.date, and then we will create a new object. So we can do date now equals new date. So just like that, we have created a date object, and then we must also import another library just so that we can format it. Because right now it's going to print a Unix time, which is going to be a random jumble of numbers. We got to format that. We're going to do java.text.simple. Let's see, simple date format. And that is not the correct library. Let's see if I remember that correctly. Simple date format. Maybe it is in java.utility. Oh, I am very okay. I'm very sorry. Type simple data format, supposed to be simple date format. There we go. I was wondering what was going on. Alright, so we gotta format this so that it looks readable. So again, this is a class. It's just packaged. So we will do simple date format equals new simple. I know it's pretty long, but just gotta deal with it. Passing the constructor, and the constructor takes a string, which is basically a string. It will take, for example, we can format this into I'll just give you a simple one. Let us do the week of the day, and then we can do the actual year, month, day, or if you're using imperial system, month, day, year. Let's just do that, and then hour, minutes, seconds, and then, okay, well, let's just go from here. So to do the day of the week, we just type E, and that's pretty much it. It's just E. So wherever you place E, so you can do E like at the very end, and then you can put, year, day, whatever you do, but let's put week at the beginning, because you usually say the time of the recording of this video will be Sunday, November 14th. So, I mean, not Sunday, Saturday, November 14th. And so to do that, we will say the day of the week first. So you just type E, and then let us format the actual date. So I'm going to do it in imperial, but just like it can also work with the metric formatting, which is this, right? But most people do that, and day, year, like that, and then we can do a hour, minute, second. So that's universal. I don't know anybody else who doesn't use hour, minute, seconds. And we can throw in some, meridians in there. We can do a meridian. So that's just type A for the meridian. Either the AM and PM and then we can do the time zone, because time zones are important in letting people know what time zone it is. Usually, if you don't specify time zone, it will be in Universal Coordinated Time. But if you do, it'll be your local computer's time, which will be synchronized with your time zone. So there's a full list online. For example, you can also do like other stuff like week of the month, day of the month, and then we can also do that. So let us print this. So we can do system.out.print line. So let's see what is now. So basically, let us print the current time. So format, we're gonna format now. So now is our date object because we're formatting it. Let's run it. You can see again Saturday, November. And I actually formatted this wrong. Apologies to me. It shouldn't be colon. That looks like a timestamp. Gotta do slashes just to make it look better. Or we can do dashes. It doesn't matter. So Saturday, November 14th, 2020, which is gonna be this year. And then you can see right now it is 4:23, 43 seconds. And I'm recording this in the afternoon, so I mean the Eastern time zone of the United States. That's where I live, so that is the timestamp. And just to make sure that nothing went wrong, you can see that Eclipse automatically timestamps it. So you can see that we started running for we can start running this at 4:23:42, and then we ended it at 4:23:43. So it takes about 1 second for it to run, which is average for a program. But just to make sure that is right, that is how date works. Now, besides knowing the date, you can also probably create a clock. And to do that, I am going to show you another feature that Java has, which will help you create a clock. So we can combine this date format, and we can actually make a clock that ticks upwards, each time you run the program. So to do that, let us remove all of this date and month, because we just need a simple clock. And you know what? Let's keep the time zones in. And to do a clock, well, that'll be very easy. So all we have to do is we're going to leave this out of the loop, because yes, you have already heard me. We're using a while loop, and we're using a infinite while loop. I know, yes, gasp. We never use infinite loops except in a certain circumstance. So we can actually pause the Java thread for 1 second. So to do that, we want to import again. This is one of many of my favorite libraries, but another one is java.unit.concurrent, right? And then you want to do import time unit. So time unit. So just remember that. And what this will do is it will pause the thread so that your CPU doesn't heat up or anything. So let us see how we can tackle this in making the clock. So to do that, we gotta keep on getting the date or the time right now. So we have to print these two in the loop, but we don't need to format it each time, because I think all it will do is it will format this. So this is the constructor. This is the actual method that's formatting it. So as long as we leave this in the loop, this should be fine outside the loop. So let us do that. To do while true, again, never do this without supervision. And by supervision, I mean without the sleep function, which I'll show you right now. So you can see Eclipse already threw an error. If you have a while true loop, you can never get to here. So we just move that in. Alright? And again, which means that this program will never end until you kill it. Which means that, it's a clock. It's a working clock. It doesn't just end by itself. But remember, we will have to sleep. So to do that, we do time unit. dot sleep seconds or seconds dot sleep. So let's sleep for 1 second. So let us see if let us throw a interrupted exception, because that's what it takes, an interrupted exception. So now let's run this. You can see it should be a clock for us. And when you look at that, it is ticking upward by 1 second. You can just embed it, into a GUI or like a applet or whatever you want to do. But that is how you create a clock. You can see we can also refine this clock, because you can see it's printing the previous, the previous the previous timestamps, and that looks very, very cluttered. So to do that, we can counter that by using the flush statement. So to do that, we will actually import this IO exception, because remember, the console is a input alpha stream. So import java.io exception. And yeah, okay, so now we gotta throw this exception just so that we can handle it. Again, exceptions, they will exist the more you work with APIs. It's just how it is, because sometimes your computer just decides that, it will act up. So to do that, we will do, actually, we don't need to, we probably don't need to do a IO exception, because I have a better method that doesn't require a library. Yes, it doesn't require a library. So let's remove this IO exception, and we'll just only throw one exception. But what it does require is our custom defined thing. And to do that, we will create our own we'll create our own method to clear the console. So to do that, we want to do public static final. So or we can just do static public static final static. So again, we'll make this a constant function, public void return type clear console. Let us do clear console, and then let's make sure there's no errors. Alright, and then we will actually do a try catch statement, but not with the IO string. Not with the IO exception. We will catch any exception, which I'll show you. Again, another cool trick. You can catch any exception by doing this simple thing. So we can do catch just generic exception E, and this will catch any exception. So it can catch interrupted exception, it can catch IO exception, but the catch is, get the pun, the catch is, you wouldn't know the actual, because the catch is to handle the exception. So what will you handle the exception? Because what will you print? So you don't print, you just do e.print stack trace. So that will just tell you what's wrong. And let's just leave that there. And then, so to do that, we can use the system library, which we can define the final string OS. Now this will access your OS. Now, not actually access it. It'll read from it. And in my case, I am obviously using a Windows 10 computer, so I will type system.get property. Can we get property? And we will get a property called os.name. So you can see this works for any devices, because whatever operating system the Java virtual machine is on, it will automatically get the OS name. So if you're running this on a Mac, it'll still work. You don't have to change any of the code, because this property will tell Java that you have a Windows computer, Mac computer, or a Linux computer. So that is how we get the property. Now make sure that we can counter this by, for example, in my thing, I use Windows. So if OS, right? If OS that contains, now Microsoft is different from the Linux distros, so we have to do an exclusive if statement just for that, because Windows, if you want to clear the console, you have to do runtime .get runtime, and let us complete that. There we go. It's just a little slow, and then we can execute, and then Windows has this CLS, which is a command line of clearing the console. So again, that's for Windows. That's why we do the if OS contains Windows. Because if you're on Linux, you can do if OS contains Linux, and then you can do execute, some Linux command here. Of course, I know the Linux command for clear. Well, I just said it. It's clear. So to clear, flush the stream. For Linux, you do clear. But for Windows, since I have Windows, we do CLS. So now we just gotta run this right before the sleep. Yes, because we gotta clear it before. Hopefully this will work, because if it doesn't, it might be exclusive for, it's exclusive for the command prompt. So if we get open command prompt, it will work. But we can also, since we're in Eclipse here, it doesn't work for the command prompt. So to do that, we can also counter this by using, so many of them use Linux, but we can try to see that it is very different depending on the software you use. So flashing the stream, it depends. A lot of people use this method, but that's for command line, because you can see that Eclipse can't recognize CLS. But if you open a command prompt, Eclipse will recognize it. Not Eclipse, but Windows will recognize it. So this wouldn't work for Eclipse, but if we run it on a command line, this will work. So it's not useless. It still works, just not on Eclipse because of the IDE issues and stuff. So we can also do a naive implementation just to show you that it works. We can, for example, all we have to do is we can go back to the Eclipse console and we can edit all the settings to make sure. But to do that, we can also just do for int I. Again, this is very naive. I suggest you use the previous one for a command prompt. But just to counter this, because Eclipse is stubborn and it doesn't want you to clear, you can see there's a lot of IO exception and all of that. So we can do that by using a new line. So we do, if I equals 0, I less than 50, I plus plus, we can do system.out.println with nothing inside. That way it'll just create a bunch of random new lines. So you'll have to, you can see again, Eclipse is also bugging out, but you can sort of see that it is slowly counting up. In fact, let's stop this and let's move this down here. Let's see how much line is this? 1, 2, 3, 4, 5. So let's do 5. So that should be better, because Eclipse has a hard time formatting 50 lines. And again, you can resize this, but I'm not gonna go detail into how Eclipse works, because the very beginning I did promise that if I teach this, I wouldn't go, play with the IDEs, because the IDEs are specific. You can use Notepad to run Java, and Notepad might not have these fancy features. So I want to keep it fair for everyone. So I'm not gonna mess with Eclipse, but you can see we have a working clock. Still badly formatted, I know, but you can see it creates that flushing format, because you can see it is constantly creating new line buffers, and then it creates this basically stop motion picture. So that is it for the time. So we just created a simple clock that counts upward, and that doesn't have like a bunch of crap like running with the other things that coming out of the output stream. So let's admire this clock for a while, or for like 2 seconds. But I'm just gonna leave that here, and in fact, I'm just gonna leave it all here. I don't have much else to say other than remember, this is how you sleep, and the date format, remember random format too. But I guess other than that, that is it for this tutorial. Everything else, leave it up to you. Again, I keep on saying, look at how many libraries there are. These are all for you to explore, not for me to teach. I wouldn't, I can't probably teach this in my lifetime. There is literally hundreds upon hundreds of libraries. And don't forget about custom libraries like Google main libraries, Amazon libraries, all support Java. So, but I assume that you will have the basic understanding to use those libraries and to do great things with them. So, that concludes the series. I hope you enjoyed the series as much as I did, because I have something special planned, which is exactly 1 day before this video goes up. I mean, after this video goes up. Obviously, we can't do before. But exactly 1 day after this video goes up, I will premiere a live stream, and this live stream will be a few hours long. But what it is it's combined every single video into one. So you wouldn't have to click through all the videos. I call it a video marathon, but it's really just all the videos combined into one. And it should be, all in one package specifically for you guys to watch. And that way, it will start from episode 1 and it will end right here. But again, I'm just saying, from very beginning, Java, very, very powerful language. Very powerful. In fact, it is equally as powerful as C++ and Python and JavaScript and all of the other, buzz languages you're talking about. This language gets thrown under the bus because it takes a fair amount of learning to master the language, unlike, some other languages that can easily be mastered. But that is what we're here for, to learn and to strive. So, again, I hope you stay safe out there. I'll probably be, after this video, I'll probably be going back to my normal schedule uploads. So don't worry, I'm not leaving the channel. It's just this series will be a wrap. And again, I thank you for watching this video and the series. If you enjoy the series, leave a like, and that will help me work on future series. Who knows? Maybe I'll make another series. It depends. But again, if you enjoyed this series, please give a thumbs up. And yeah, have a good one.